Hello, hi, namaskar everyone. So let's get started with our discussion on the chapter Determinants, where we have promised you that we'll start from scratch. The NCRD level will start. We'll complete all the theory comprehensively. We'll understand all the basics and gradually we'll take you towards the JEE level questions. Absolutely, indeed. Yes, that's the whole point. That's the whole motive and that's the whole idea of these sessions. So I'm sure most of you have joined, most of you have started watching it, and let's get started. Are you all there watching it live with your sincerity, with utmost sincerity? Great. So shall we get started, everyone? Hello, hi, good evening, namaskar, everyone. We are getting started with our discussion on determinants. I hope you do remember that in this discussion, we'll be using our Pylons application for the purpose of conducting polls. How can you participate in the polls? So to participate in the polls, all you need to do is download this Pylons application from Google Play Store if you're watching it on the mobile phone. And if you're watching it on your browser, that is on your system, laptop or desktop, you can download it from the Chrome store. I can participate in the polls. Sir, is it just for the purpose of participating in the polls only? No, absolutely not. Just that. Let's say you're watching any random video, non-PY, PW video as well. Then also to generate, let's say, summary or even PYQs or the mind maps or some other PDFs relevant or related to that video, you can generate with the application Pylons. Shall we get started, everyone? So here we are with the chapter Determinants. Its discussion. We'll be majorly doing what all things. We'll start our discussion with basics of determinants. So we'll understand what all are determinants. Then, of course, we'll talk about cofactor and minors. Then gradually we'll move towards the different methods or properties to expand the determinants. And once we are done with the expansion of determinants, we'll gradually move towards properties and all. And then we'll talk about determinant, its different properties, and then its applications in coordinate geometry as well, that how do we apply coordinate geometry or determinants in the coordinate geometry. Then we'll learn Cramer's rule as well, that how do we apply Cramer's rule using determinants and solve system of equations, system of linear equation, system of non-trivial equations as well, and a system of homogeneous equation where you talk about non-trivial solutions and all that. Yes, that all also will be discussing and discovering. And yes, with this all, of course, not just that, with this all, we'll gradually move towards your JEE level questions as well. First of all, sir, why do we have determinants? Yes, this is the full chapter one shot. I'm promising and assuring you that with this one shot, you'll get complete clarity, a decent crystal clear clarity of this whole entire chapter. Yes. Now, I hope you remember that. Let me give you a basic idea, a very systematic, simple idea. Let's say I'm solving two equations in two variables. A1x plus b1y is equals to d1, a2x plus b2y is equals to d2. So the two variables are x and y. I'm having two equations. So what did you used to do? Sir, definitely you can. You definitely can. If that is the purpose you're trying to fulfill here with that. Definitely. So, sir, do you remember that substitution or elimination method? But what if I tell you, if that whole is looked at from a little different perspective, an absolute different idea was suggested by Cramer as a mathematician. What did he suggest? He said that if you find the determinant, sir, what is determinant? How do we find it? I'm going to tell you very soon. But for a while, let's assume there is some operation which is called the determinant. So first of all, you find the determinant of A1, B1, A2, B2. You find the determinant of A1, D1, A2, D2. You find the determinant of B1, D1, B2, D2. So I'm asking you to find three determinants. Sir, what is determinant? How do we find it? Have patience. I'm anyways going to tell you in the next slide. But have patience. I'm just asking you. Thank you so much, my dear friend. I'm just asking you to learn three things here. A1, B1, A2, B2. A1, D1, A2, D2. And B1, D1, B2, D2. These three determinants, let's say if you have found, then with these three, Cramer suggested that you can find out these variables x and y without even using substitution or elimination. Sir, is that really not already very complicated? We know some really simpler methods. We know some really simple idea that either you apply substitution or elimination, you can directly get the answers very quickly by solving these two linear equations. But what is the point of making it unnecessarily complicated? As we know, genius is keeping complex things easy, not easy things complicated. So what is the whole point of doing it? The whole point is I am taking a simpler example to make you understand the complex concept. Let's say if I'm given more complex equations, that means more variable based equations, let's say 3 equations with 3 variables, then of course calculation goes a little lengthier. 4 equations with 4 variables, trust me, their Cramer's becomes more handy, that Cramer's rule, which we'll be discussing somewhere in the middle. But right now I'm trying to tell you the real world application of determinants, that it is not only used in solving linear equations, it is used in solving, finding the area of any polygon, finding the area of any triangle, and a lot of other features it has, which we'll be discussing in your entire journey of 11th and 12th. Very soon, once things start getting unfolded, you will start noticing it. Definitely, Daman, that's what I'm suggesting and saying. So what Cramer noticed was that if you find few things, which few things? If you find this determinant A1, A2, B1, B2, if you find one more determinant D1, B1, D2, B2, if you find one more determinant A1, D1, A2, D2, if you find these 3 determinants, and if you simply divide this determinant by this determinant and divide this determinant by this determinant, trust me, you will have X and Y at your fingertips. Sir, is that all? Is that all? But how do we find determinant? What is determinant? Are you not supposed to tell us that? Yes, very soon in the very next few steps I'm going to. This part I'll definitely be explaining very soon in the almost probably middle of this chapter. I'll come back to this. But right now, I just want you all to understand how do we expand a determinant? Shall we? Everyone pay attention. So as long as a 2 by 2 determinant is considered, determinant is technically like an operation, like addition, subtraction, multiplication, division, modulus. These are all mathematical operations you perform on numbers. So similarly, let's say this is a 2 by 2 determinant. So a 2 by 2 determinant means it has 2 rows and 2 columns. So 2 rows and 2 columns means what? It will have elements, it will have numbers. The way you have data arranged in an Excel sheet, it has rows and columns. Similarly, matrices and determinants are technically rows and columns. But matrices, when they are square, which means if number of rows and columns are same, there we take the determinant of them. So a determinant means number of rows and columns will be same, 2 by 2, 3 by 3, 4 by 3, and so on. But remember this, in your syllabus is restricted to a 3 by 3 determinant. Very rarely you could be seeing a 4 by 4. Now, sir, we are still clear that let's say 2 by 2 means a square, row and column, 2 row, 2 column. But what are we supposed to do with that? I am saying, let's say if it is a 2 by 2 and let's say the data is put here like this 2, 3, minus 1 and let's say 4. Then what are we supposed to do? Let's say I'm calling it to be delta here. You're denoting it like this. No, nobody is late. Everyone pay attention here. Now, if I want to figure out how do we find the determinant? I'll say multiply this element with this element and then multiply this element with this element. And from this product, subtract this product. This is the standard ideal method of expanding a 2 by 2 determinant. What does it mean? It means this 2 into 4, this 2 into 4 minus this minus 1 into 3. That's how you expand a 2 by 2 determinant. Isn't it simple and easy? With this 4 into 2 is of course 8, 3 into minus 1 is minus 3, minus plus, that's your 11. So that's how you expand a 2 by 2 determinant. Everybody understood that? Everybody got that? Yes or no? Now, if you have gotten that, let me talk about the expansion of a 3 by 3 determinant. So what is the meaning of a 3 by 3 determinant? For a 3 by 3 determinant, the whole idea is you can expand it with respect to any row or any column. Our determinant of 3 by 3 can be expanded with respect to any row or any column. Remember this. But let's say to explain this, I have chosen the first row. So for a 3 by 3 determinant, I am choosing the first row. So I am willing to expand it with respect to the first row. So I have now started or decided that I'll be expanding it with respect to the first row. So what you do is you write the elements of the first row, which are A1, A2, and A3. Sir, we have written them, but what do these sign means? Plus, minus, plus. What is the meaning of these signs? Have patience. I'll tell you. And how am I writing, or on the basis of what logic am I writing plus, minus, plus? That also I'll tell you. But right now, let's accept it as a fact. Very soon you will start digesting everything with the concept of minors and all coming into picture. But right now, have patience. Patience is the key. Pay attention, everyone. So, first row with respect to which I am expanding this determinant, which means I am finding out its value. And with this, I have these elements A1, A2, A3, where I'm following a certain sign scheme, plus, minus, plus before A1, A2, and A3. Now, I want to find what will I write along with A1. So just remove the row and column which contains A1. So am I not left with these four elements? Just write these four elements and find out their determinant. Then we wrote A2 with the negative sign. Sir, why negative? Have patience. But with this A2, remove the row and column which contains this A2. After this, am I not left with B1, B3, C1 and C3? So if I'm left with these four elements, just write the determinant of these four elements and multiply it with A2. Then what? Then write this A3. This is contained by first row and third column. Remove them, and after the removal of them, I am left with these four elements. Yes or no? So write these four elements and its determinant and multiply it with A3. That's how you will find the value of this determinant. Shall I repeat it? Let me do it with an example. I think there it will be more understandable so that it becomes more clearer. Let's say I have chosen an example. Which example, sir? Let's say there is a data 2, 3, minus 1, 0, 5, 7, 4, 2, and let's say 1. This is what? A 3 by 3 determinant. This is what? A 3 by 3 determinant. And in this determinant, I am wanting to find its value. So let's call it delta for a while. So here, I am expanding it along the row 1, let's say, just to keep it simple and understandable. So I'm expanding it along with the row 1. I hope no confusion so far regarding that. Yes or no, everyone? So I have expanded it along with the row 1. Yes or no, everyone? Now, with row 1, if I'm willing to expand it, what happens now is that this row, first row you have chosen. So write down these three elements, 2, 3 and minus 1. 2, 3 and minus 1. So if I write these elements, 2, 3 and minus 1. I have written down these three elements, yes or no? Now, follow this sign scheme for the first row, plus, minus, plus. Technically, this is the sign scheme which you can always remember for a 3 by 3. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Sir, what is the logic behind this? Can you explain that? Yes, very soon, very soon. But have patience. I'll tell you. But right now, digest and accept it as a fact that this is the sign scheme we follow while expanding a determinant. So I have chosen the first row. I have chosen the first row. Yes or no? So if I have chosen the first row here, for the first row, the signs are going to be plus, minus, plus. So before 2, the sign should be plus, which I have put here. Before 3, the sign should be minus. And before minus 1, the sign should be plus, which I'm putting here like this. Everyone comfortable and okay with this? Yes or no? Yes or no? Now, pay attention, everyone. Now, with this 2, what you're supposed to do is remove this row and column. You're left with these four elements. Just find out their determinant. What do I mean by that? I am now left with these four elements, 5, 7, 2, 1. So I'll find the determinant of 5, 7, 2, 1. Getting it, everyone? Yes or no? With this, when I talk about this minus 3 has this minus because of this sign scheme. Yes or no? But if I forget this sign scheme, if I look at this number, this 3 as an entity here, 3 is contained by this row and this column. First row and second column. So I am left with these four elements. So here, if these four elements I am left with, I'll find the determinant of these four elements. Which four elements here? 0, 7, 4 and 1. 0, 7, 4, and 1. And I hope I need not tell you how do we find the determinant of a 2 by 2 determinant. Yes or no? With this, the next part. With respect to this minus 1, again I'm supposed to apply the same logic. Which logic? Remove the row which contains minus 1, remove the column which contains minus 1. So I'm left with these four elements, 0, 5, 4, 2. So I'll write the determinant, this 0, 5 and 4, 2. Yes or no? For this minus 1. So determinant will be 0, 5, 4 and 2. Everybody understood that? How am I doing it? Yes or no? Great. Now, what I do next is pay attention, everyone. That's even interesting. Here we are with this. Let's say now I'm willing to expand it. I think now you have the answer at your fingertips. Why not? Because this 2 is 2, but this 2 is multiplied with, this 2 here is multiplied with this 5 into 1, which is 5, minus 2 into 7, which is clearly 14. Everybody got that? Yes or no? Then the next thing, you have this minus 3 times whole of 0 into 1, that's 0, minus 4 into 7, which is minus 28. Getting it, everyone? Then minus 1 times 0 into 2, that's 0, and 4 into 5, that is 20. Everybody understood that? Everybody got that? Yes or no? So I hope this part is very well understood by everyone. Yes or no? Yes or no? Give me a quick update, everyone. Give me a quick update, everyone. Everybody getting this? Now with this, I hope the calculation is really simple. 5 minus 14, that is minus 9. Minus 9 into 2 is minus 18. That is minus 28 into minus 3. Triple of 30 is 90. So minus 6 if I do from 90, this will be triple of 28. That is 84 and plus 84 I'll have. So this will be plus 84 and this will be plus 20. So I think we have the answer because 20 minus 18 is 2. 84 plus 2 is 86 and that's your expansion. What does it mean? This means, let's say, if I want to expand it with respect to some other row or some other column, there also I'll get the expansion as 86. I'll not demonstrate it completely, but I'll show you how. Let me take another way of expanding it. Let's say I have chosen the second column just to make you understand this. So instead of first row, I am now expanding it along with the second column. And that's the whole point, that you can expand it with respect to any row or any column. So let's say I'm choosing second column. Now, when I have chosen the second column, these elements I have chosen, yes or no? These are the elements which we have chosen. So now, again, if I get back to this idea, these elements are 3, 5, and 2. So write down these three elements, 3, 5, and 2. Everyone getting that? Now, sir, aren't we supposed to follow the sign scheme? Yes. So for the second column, the signs are minus, plus, minus. So before this 3, you put a minus. Before this 5, you put a plus. And before this 2, you put a minus. Everybody got that logic? Yes or no? With this 3, I hope you know what are you supposed to write is, sir, remove the row and column which contains this 3, and with this I'll be left with 0, 7, 4, 1. Yes or no? So I'll write this 0, 7, 4, 1. Yes or no? For this 5, what am I now supposed to do is remove the row and column which contains 5, and with this I'm left with 2, minus 1, 4 and 1. I hope no confusion regarding that. So I'll be left with 2, minus 1, 4 and 1. Now the next thing, with respect to this 2, again I'll remove this third row and second column, so I'll be left with 2, minus 1, 0 and 7. Yes or no, everyone? So with this I'll be left with these 4 elements which are going to be 2, minus 1, 0 and 7. Again, I hope now you are very much comfortable with this task. How are we supposed to do it? Yes or no? This into this, 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 and this into this. And ultimately that product is multiplied with these individual elements, and then that whole sum will be my final answer. or the expansion or the value of the determinant. The whole point which I'm trying to make you understand is this, that whether you expanded with respect to row 1 or with respect to second column or with respect to any other row or any other column, the value of the determinant remains same. It remains unchanged. Whatever I have explained so far was really simple and straightforward related to this whole idea only. Let's say if I have a determinant which I'm denoting by delta. Now its elements which are positioned at different locations are taken. Just hold on for a while, students. Are taken like this A11. So here this A11 means that you're talking about first row, first column. A22 means second row, second column. A31 means third row, first column. A23 means second row, I hope you're noticing, and third column. So I hope this indexing is very well understood by you all in determinants. Now this indexing, if you're able to understand, will help you in understanding the sign scheme. I repeat, let's say I give you two terminologies. First terminology, let us understand what is a minor here. Here only, let us understand the concept of minor. Now, if I am going to explain minor, please pay attention. That's a really simple, straightforward concept. Minor simply means, let's say, I want to find out the minor of A21. I want to find out the minor of A21. So how do you find the minor of A21? To find the minor of A21, remove the row and column which contain this A21. Then what am I now left with? I am left with these four elements, A12, A13, A32 and A33. Just find out their determinant, which means if I find the determinant of A21, A13, A32 and A33, this will be the minor. Got it? Yes or no? So in that same fashion, if I ask you a simple example, if I give you a simple example, let's say 1, 2, 3, 1, minus 1, 0, 7, 4, 6, 5. And here, let's say if I ask you to write the minor of 7, what will be your answer? Sir, minor of 7 you are asking. So for minor of 7, remove this row and remove this column which contains 7. So I'm left with which elements? I'm left with 2, 3, 4 and 6. So write down these four elements, 2, 3, 4 and 6. Yes or no? So with this 2, 3 and 4 and 6, I hope you know how to find out the determinant of a 2 by 2. So sir, for a determinant of 2 by 2, 2 into 6, that's 12. 4 into 3, that's also 12. So that comes out as 0. Here it is the minor. Everybody got that, or shall I re-explain that? Give me a quick update, everyone. Yes or no? Yes or no? Yes or no? Everybody with me on this? No confusion so far? Yes or no? All the participants. Shall I move ahead from here? Now, with this, if you have gotten a decent clarity on this, I will now explain the concept of cofactor. I'll come back to the concept of cofactor. What is the concept of cofactor? Let's talk about that as well. I did not say that we are teaching you NCERT only. We are teaching you from scratch, from basic, from that NCERT level to the JEE level. And very soon in this very session only, you'll be seeing questions of JEE mains getting solved from scratch. Yes, that's the whole point or the idea of this session. Cofactor. Cofactor is technically an extension of minors. Sir, what do you mean by that? I mean to say that here, let's say if I ask you to find the minor of A32, what is the minor of A32? So sir, minor of A32 if you wish to write, minor of A32 if you wish to write, it will be remove this row and this column. And then what are we left with? This, and this. Find out their determinant. Find out their determinant. So sir, its determinant is A11, A13, then A21, and that's A23. Yes or no? Now, once you have found the minor, your job is done. Why? Because if I simply multiply this with minus 1 to the power of index of A32, which is sum of A32, which is sum of row and column of A32, which is 3 2. That is third row, second column. So 3 plus 2 is 5. Minus 1 raised to the power 5 is minus 1 raised to an odd power. Minus 1 when raised to an odd power is minus 1. So cofactor of A32 is nothing but minor of A32 only with a simple change, which is this, that here, give me a moment, which is that minus 1 to the power row plus column. Shall I repeat that? Pay attention, everyone. If I could give you one more example from this question only, I think this is a good question here. With this question, or even with this example which we have taken here, let's say I want to find the cofactor. I want to find the cofactor of, let's say, this 7. Can we find? So cofactor of the 7, I think 7 we have already found. So let me use some other number. Let's say we are finding the cofactor of this 5. Can we do that? So cofactor of this 5 is going to be what? So first of all, find the minor. What is the minor? So for this 5, the minor is going to be really simple. For this 5, the minor is going to be really simple. Remove the row in column. Remove the row in column which contain this 5. So this row and this column, if you remove, are you noticing that you are left with these 4 elements? Yes or no? These 4 elements are 2, 3, minus 1 and 0. You find out their determinant, and for a 2 by 2, we know how to do it. Then the next thing which we do is minus 1 raised to the power minor multiplied with minus 1 raised to the power the index of this 5. This 5 is positioned at third row, third column. Third row, third column. So this minus 1 raised to the power 3 plus 3. 3 plus 3 is luckily 6, which is even. Minus 1 to the power even is plus 1. And plus 1 here will give you plus 1 into something. That's something. So here 2 into 0 is 0. Minus 1 into 3, that's minus 3. Minus of minus 3 is plus 3. And that's your cofactor. I'll explain it very soon. In the next chapter, when we cover matrices, there we'll talk about that. But right now we are covering determinants. So let's restrict or confine our discussion to determinants only. But I'll definitely do it. Don't worry about that. So did you all get this? I repeat, my discussion so far was related to minor and cofactors. Yes or no? Yes or no? Everyone. Yes or no? I repeat, the whole point is really simple. I repeat that if I'm talking about the minor of, let's say, this element A21. So remove this row in column. You're left with these 4 elements. Find out their determinant. It will be the minor. Let's say minor of 3, 2. So third row, second column. You're left with these 4 elements. Just find out their determinant. It will be the minor. I hope it is easy, understandable, and absolutely clear. Sir, how do we find the cofactor? So to find cofactor, it is again simply do nothing but this. Put the sign scheme as well. Sir, how do we understand or learn the sign scheme? I repeat, just add these values. If their sum is even, it will be plus 1. If their sum is odd, it will be minus 1. Because minus 1 raised to the power sum of rows and columns. So I hope you remember 1 plus 1, 2, even, plus 1 plus 2, 3, odd, minus. So I hope you're realizing consecutively it will be plus, minus, plus, minus, plus, minus, plus, minus, plus. Do you now understand the logic? Plus, minus, plus. Why were we following that scheme? Why did I tell you that sign scheme which you're supposed to remember here? And I hope you now must have understood that whole logic. Yes or no, everybody? Did you all get that? Shall I move ahead from here? I hope so far there is no confusion regarding minor and cofactor. Everyone comfortably got that? Everyone comfortably got that. Now, sir, why are we learning this concept of minor and cofactor? What is really the need of it? The need is absolutely simple. If you are having certain elements of certain row or column, any row or any column you choose, let's say I have chosen the first row. So the elements of the first row are A11, A12, A13. So write down those elements A11, A12, A13. And with these elements, if you multiply them with their minors, so A11 had the minor this, A12 had the minor this. I hope you remember that. I hope you do remember that, these four elements. And A13 had this as the minor. Do you remember that? So if you multiply any row or any column's elements with their corresponding minors, and with that, if you follow the correct sign scheme. So what is the correct sign scheme? A11, 1 plus 1, 2, even plus. A12, 1 plus 2 is 3, odd, minus. 1, 3, A13, 1, 3 is 1 plus 3, 4, 4 means even, plus. So if you simply follow this correct sign scheme, your job is done. Plus, minus, plus, that's your value of the determinant. And the beauty here is that with respect to whichever row or whichever column you do it, it will always remain same. I mean to say that even if I write this column and multiply these elements with their corresponding minors, and if I follow the correct sign scheme, I'll again get the same value delta. Getting my point, everyone? Let's say I am expanding it with respect to the third column. I am willing to expand it with respect to the third column. So I have chosen third column. Third column means write the elements of third column, A13, A23 and A33. Everyone getting it comfortably? So for A13, 1 plus 3, 4, sign will be positive. 2 plus 3, 5, odd, sign will be negative. 3 plus 3, 6, even, sign will be positive. First of all, did you get it? Now I hope you know for A13, the minor will be this. Can you imagine and visualize this? So this will be the minor of A13. With A23, the minor will be these four. I hope you're understanding. So I'm denoting it by M23. For A33, I hope you're realizing the minor will be this. So I'm writing it as M33. And if you do this sum, you will again get the same delta. Getting it or not? I hope you are getting it comfortably. Now, if I extend this concept to cofactors, I think there you'll get more clarity with the concept of cofactors. That, sir, cofactors are what? Minors when assumed with the signs will give you the concept of cofactors. Do you remember that? So, let's say if I have chosen A11, A12, A13, the first row, yes or no? And with this, if I multiply them with their corresponding cofactors, Now, sir, why are you not putting a minus sign here? Because that C12 already contains that minus, because C12 is minus M12. Thank you so much, Hema, but I hope you are understanding it. Yes or no? Because I hope you remember, if I talk about C11, that is M11 only, because minus 1 to the power 1 plus 1, which is 2, is plus 1 only. If I talk about C12, which is minus 1 to the power 1 plus 2, which is odd, M12. So I hope minus M12 can be replaced by C12. And similarly, if I talk about C13, that will be minus 1 to the power 1 plus 3, M13. So I think that's exactly what we were doing. 1 plus 3 is 4. 4 is even. So it will be plus M13. So it used to be A11, M11 minus A12, M12 plus A13, M13. So that minus MA12 has not vanished anywhere. It is now just written as C12. Sir, why are we discussing all this? Because I want to give you something really important here now at this stage. Remember this. And this fact is very widely used in IIT-JEE. What is that fact? If you take any row or any column, and those elements of that particular row or column, if you multiply with their corresponding cofactors, I hope now you know how to find cofactors, then you can always find the value of the determinant. So that's it. That we already knew. No, that's incomplete. The second information. If you take any row and you multiply the elements of that row with the cofactors of some other row, the value of that expression will be 0. What did I just say? I said two things. Let's say A12, A22, A32. These are the elements of second column. I multiplied them with their cofactors C12, C22, C32. I hope you understand what are cofactors. So that will always give me the value of the determinant, which we are denoting by delta. But let's say if I do this A12, A22 and A32. What is this? 2, 2, 2, second column. Elements of second column, I am multiplying with the cofactors of first column. I hope you're understanding. First column means what? C11, C21 and C31. And if I add it up, will it still give me the value of the determinant? No, it will not give me the value of the determinant. Sir, why? Because if you multiply the elements of any row or any column with the cofactors of some other row or some other column, the value of that expression is 0. But if you multiply elements of any row or any column with their corresponding cofactors, it will give you the value of the determinant. First learning for JEE. Have you all understood it? From very basic scratch of the understanding of determinants, we have gradually taken it towards minors and cofactors and the expansion of a determinant and this very beautiful, insightful, crucial property which you are supposed to remember. So are we clear on this? Yes or no? I repeat, sum of the products of the element of any row or any column with their corresponding cofactors is always equal to the determinant, the value of the determinant. But if I take some row or some column or multiply them with the cofactors of some other row or column, I hope you remember the value of that expression is going to be 0. Will you all remember that? Yes or no? Yes or no? Everybody, give me a quick update. Everybody understanding this whole idea? Everybody comfortable with whatever we've done so far? Yes or no? Now with this, if you have gotten this whole idea, that's what I'm saying, that sum of the product of elements of any row or column with the cofactors of some other row, any other row or column is going to be 0. Remember that. IDJ not just mains, but yes, it has asked you questions based on that as well. That they gave you a row or column or a determinant and they asked you to multiply that row or column with its some other row or column's cofactors. Then of course, even without calculating it, without even lifting your pen, you could have directly stated the answer that yes, by using this property, answer is going to be 0. And that's how or where you say that yes, it is a short trick. It is actually not. It is simply an observation which you are good at. You can crack the questions. Everybody got this? Shall I move ahead from here? I hope no confusion on this. Which means, let's say if I give you a determinant 2, 3, 1, 7, 5, 6, minus 1, 4, 2. So let's say I ask you a value. Which value? Let's say I ask you a value 7, 5 and 6 multiplied with 7 multiplied with the cofactor. Cofactor can I write as COF? I hope it is understandable. Cofactor of minus 1 plus 5 multiplied with cofactor of 4 plus 6 multiplied with cofactor of this 2. Can you help me with the answer here? Can you help me with the answer here? Can somebody quickly write the answer in the comments? I hope most of you must have noticed by now that, sir, elements which you have chosen are 7, 5 and 6, which is your second row. Cofactors you have chosen are minus 1, 4 and 2. So you are choosing the cofactors of row 3. So elements of row 2 are multiplied with the cofactors of row 3. Will it give me the value of the determinant? No. It will give me, write in the comment box, students, the answer. The answer will be 0. Yes or no? Yes or no? Because this is a property, it's a property which you all have now comfortably understood. Shall I move ahead from here? Everybody understood this whole idea? Yes or no? Everybody, be quick. So far, whatever we have learned, let's learn few more things so that we can get more comfortable and accustomed and familiar with the determinants and its expansion. Second thing, let's say if I ever get a determinant, and in this determinant, if I ever notice any two row or any two column are identical, any two row or any two column are identical, in that case, you can unhesitatingly say that its value, the value of the determinant is going to be 0. Shall I repeat that? If you ever see any two rows or columns to be identical or same, you can always conclude that the value of the determinant will be 0. You can prove it by yourself. I'm keeping that proof aside. I'm just giving you a simple fact or a property which you got to remember. And I hope you will always apply it. Second thing, if all the elements in one row or one column are 0, if all the elements in one row or one column are 0, then also the value of the determinant with respect to whichever row or column you expand is going to be 0. I hope you are understanding it logically now. I hope you are understanding it logically. So I repeat, if you ever see a determinant which has any of the rows or columns having all the elements as 0, so don't even try to expand it. Without any hesitation, write that its value is going to be 0. Because if any row or any column has all the elements as 0, its value will be 0. Trust me, it will always happen. So I hope that fact is very well understood by everyone. Yes or no? Now, for easier calculation, we will always expand the determinant with respect to the row or column which contains the maximum number of rows. So I'll always look for a row or a column which contains the maximum number of rows, and with respect to that row or column, I'll expand the determinant. Shall we try a question now? I hope you can see a question right there on the screen. So I'm asking you to put the answer in this poll, and I'll be really happy if some of you could tell me the correct answer. So the poll has started, it is already running. I hope you are seeing it here on the screen, everyone. And with this, let's start solving this. I hope everybody is now comfortable with the expansion of determinants. We have just learned a property. Sir, if any row or column has more number of zeros, we'll prefer to have that row or that column for its expansion so that our calculation stays simpler, easier. Remember that? So it's better that you choose the third column. So can I expand it along with column 3? So if I choose to expand it along with column 3, I'll have 4 times something that I'll write later, 0 times something, and then 0 times something. So you didn't follow the sign scheme. Yes, you can. If you're directly not writing the cofactors, you can write the minors and you can follow the sign scheme. So I hope you remember there, plus, minus, plus. So there will be plus, minus, plus, minus. So it will be minus, plus, minus, plus. So it will be plus. But are you not realizing, even if I invest or waste my time in finding the minors of this 0 and this 0, those I'll calculate and find, and ultimately them, if I multiply with these zeros, will eventually be 0, the whole product. So do I really need to put my efforts in finding them? I hope you're getting the whole logic or whole idea. But still, to make you understand the concept of minors and cofactors more clearly, I'll do it. But you really don't have to. You really don't have to. Now, sir, how do we find the cofactor here? The minor cofactors, they'll already become, because sign scheme I have followed. So for this 4, it will be these 4. I hope you are noticing it clearly. For this 4, it will be these 4, which are minus 1, 3, 4, and 1. For this 0, it will be these 4. I hope you are getting it. So they are 1, 2, 4, 1. For this 0, it will be these remaining 4, which are 1, 2, minus 1, 3. But the whole idea, which I'm constantly trying to make you understand, is that you really don't have to invest your time in expanding these. Why? Because there is already a 0, and 0 gets multiplied to anything is 0. And that's why we came up with this conclusion that we'll expand any determinant with respect to that row or that column which contains maximum number of zeros, so that our calculation becomes or stays simpler. Good, Khushi. That's brilliant. With this, I think most of you may have gotten the answer. What is going to be the final answer with this? This whole becomes 0. This whole becomes 0. So minus 1 into 1, that's minus 1. 4 into 3, that's 12, but plus, minus, and whole times plus 4. So 12 and 1, that is 13. 30 into 4 is clearly 52, but with the negative sign. And I'm sure I was asking you the numerical value. And with this, your answer should have been, of course, minus 52, but you cannot put a minus 52 here. So you should have put a plus 52 here. And I'm sure some of you might have done it. No worries. With this, shall I move ahead? Great, brilliant, excellent, Khushi. So everybody got this idea, whole idea clearly. Shall I move ahead from here? All the participants. So far, we have just learnt the concept of minors and cofactors and the basic idea of expanding a determinant. What if I tell you a short trick? What if I tell you a short trick of expanding a determinant? Will you all enjoy that? Will you all not enjoy that? Sir, what is that short trick? Saras was a mathematician. Saras was a mathematician who came with this idea that you really don't have to get into this cofactor and minor and all. You can always expand a 3 by 3 determinant by using this short technique. What was that technique? Let's talk about that. So, I am giving you a short technique which was given by Saras as a mathematician. So, it is said to be the Saras rule, which is called the short technique of expanding a determinant. Sir, how do we do that? Let's learn that. First of all, repeat the first two rows. First two rows. So, first two rows means 1, 2, 4, and then minus 1, 3, and 0. You have repeated the first two rows? Yes or no? First two rows, 1, 2, 4, and minus 1, 3, 0. You have repeated the first two rows. Now, once you have repeated the first two rows, what you're supposed to do next is start taking the product along the principal diagonal. What is the principal diagonal? This 1 into 3 into 0. Write it here. Write it here, the 0, and then add it with the next principal diagonal, which is minus 1, 1, and 4. So product of minus 1, 1, and 4 is minus 4. So add this minus 4 here. Then this product, 4 into 2 into 0. So 4 into 2 into 0 is 0. So add this here. You have taken this product. You have taken this product and then this sum. Keep it here. Keep it here. Then find one more category of products. Sir, what do you mean by that? Let's talk about that. Here, let's say if I now ask you to find out these products. Which products? Non-principal diagonal elements. So 4, 3, 4. 4 into 4 is 16. 16 into 3 is 48. I hope you're getting it. So this will be 48. Getting it or not? Then other non-principal diagonal, which is 1, 1, 0. Product of these three elements, 0, 1, 1. That I hope is clearly visible, is going to be 0. Now the next product, which is this product of these three non-principal diagonal elements, which is 0, 2, minus 1. That is again 0 because of this 0, and this whole becomes 0. Yes or no? So I found this product, I found that product. From this product, if I subtract this product, I mean sum of this product minus sum of this product. If I do, trust me, you will have the value of the determinant. That was told by Saras. Let's check it. Minus 4 minus 48. I think that's minus 52. And we have just done it. It was minus 52. It is minus 52. So that's again a very beautiful, shorter, more efficient method to find out the value of the determinant. Sir, can we use it in 12 boards? Absolutely not. NCERT or any other book or mechanism of evaluation will not allow it. They'll discard it. They'll consider it as a cheating. But if you wish to use it in IIT JEE or any other competitive exams, you must. Why should you not? Absolutely yes. Sir, why? Because it saves times. Trust me, it is less complicated. It is less time consuming and it is more direct. Sir, this looks a little bit confusing. Initially, indeed, yes. But with the time, trust me, it will be more easier, more convenient, more comfortable. Trust me. Sir, how? With practice. Trust me. So I'm sure you would start applying this method from now on. Now with this, if I try and tell you a few more questions, shall we try one more question? This question is clearly a question which IIT JEE has asked recently. In 2023, you would be seeing a question like this, that of course they did not ask you to prove it, but they asked a value of it. So if I wish to do it, there are two methods. Sir, we want to find out its value. Yes. So one of the ways is you find out its determinant by basic expansion with respect to any row or any column. But sir, if we already know a short technique, which is said to be the Saras rule, can we not use the Saras rule here? We must, we should. How? Let's learn that. So one more time, I'm explaining the Saras rule. So I'm solving it with this approach of Saras rule. Shall we? So Saras rule, if I wish to apply, how will I do it? What did he say? He said, repeat the first two rows. So first two rows means what? X sine theta, cos theta. Can I write sine theta and cos theta as S theta and C theta? Just to save some time. This is minus sine theta. This is minus x and this is plus 1. Everyone comfortably got this part so far. Yes or no? Now with this, what I'll do is simply principal diagonal. So there, if I take this product, what is it going to be? X minus x, the product is going to be, I hope you are realizing, minus x cube. Yes or no? Yes or no? The next product which I'll do is sine theta into 1 into cos theta. Of course, with a minus sign. It is minus sine theta cos theta. So I'm writing it as minus sine theta into cos theta. I hope I can write it as S theta, C theta. It is understandable, just to save some time. In boards, you should avoid doing all of this. Rather, this whole approach you should avoid. But in JEE or any competitive exams, just to save time, you should use these things. Trust me, they'll save some time. Now, the next thing which you are going to do is cos theta, sine theta in 1. That is clearly plus cos theta, sine theta. And you are not realizing this part will get cancelled. If you are getting confused, I'll write it. Don't worry. So this will be added with cos theta into sine theta into 1. So that's cos theta into sine theta into 1. Yes or no? So from the sum of these products, I'll subtract sum of these products. Do you remember that Saras rule, the shortcut we have discussed? So from here, if I subtract that, which part, students? This part. Cos theta x and cos theta. That is what? Cos square theta into x. So this will give me minus x into cos square theta. I hope I can write it like this. It is understandable. Yes or no? The next thing which I'll do is product of this 1x. It is going to be x. So this I'll do here. And the next thing is going to be, I hope everybody is paying attention, x into sine theta into sine theta. That's clearly sine square theta into x with a negative sign. So it will be minus x into sine square theta. Everybody got this? I hope now everybody is realizing it is clearly independent of theta because there is no trigonometric expression here. Sir, why? Because I'm sure most of you must have noticed that, sir, first of all, sine theta, cos theta are cancelled, nullified. Second thing, sir, minus x, if you take common, are you not left with sine square theta plus cos square theta, which is 1? So my final value or determinant after its expansion will look like minus x cube from here. And this gives me x minus x, because minus x, when you take common, cos square theta plus sine square theta will be 1. So this will be minus x plus x, and minus x plus x, I need not tell you, is 0. So your answer is x cube, minus x cube. Everybody understood that, everybody realized it, that Saras rule is such a handy approach that it can give you answers very quickly. It is very efficient and very optimum approach. So I'm sure most of you who are watching it sincerely would now start using it. That's good, Khushi. All the other participants as well who are watching it with their sincere and genuine efforts. Have you all gotten this? Yes or no? Shall I move ahead from here, all the participants? Everybody with me so far, yes or no? Give me a quick update. Let me just check the comments very quickly so that we stay on the line. Okay, great. So far, I hope there is no confusion regarding anything. Can I move ahead from here? Great. With this, if I now go ahead, the next thing. So one question I have kept here is a homework question of JEE Mains. Shall I treat it as a homework question, or let's do it? Shall we? A question asked by JEE Mains. So as I promised, told, or highlighted in the beginning. Of course, with NCERT only, you cannot crack JEE. Nobody does, nobody can. With NCERT only, no. You need to practice a lot of questions, specifically PYQs of JEE Mains and Advanced. But here, if I could say that if you are starting from scratch, if you are starting from the basics, this is a video with which we are promising you, assuring you that yes, we are trying to take you towards that JEE Mains level. One lecture is never sufficient to cover a complete chapter. Of course not, but we are trying our complete efforts so that we can give you the complete comprehensive theory with some apt and appropriate examples. But of course, to develop it as a skill, to develop a chapter as a memory, you need to practice more. So more practice you can do with a lot of previous year's questions, but conceptual clarity we'll try to give you with this video. That's our promise. I hope now everyone is comfortable with the kind of assurance or claim we are giving with this series. Yes or no? Shall we get back to the discussion we are having? Pay attention, everyone. Shall I not again use the very beautiful short technique given by the mathematician Saras? Shall I again not use that rule? Yes, we should. So here, if I wish to expand it, what are we asked? Sum of the real roots. So sir, it looks like a theory of equation based questions indeed. So I'll talk about this part later, but ultimately this will be an equation. But right now it's a determinant. So shall we start doing it? Now sir, can we also participate in this poll? Yes. How? By simply having this application Pylens. All you need to do is solve this question, get the answer without using AI, without using any other cheating medium, and genuinely come up with the response. We'll really appreciate if you're doing it with your sincere efforts, because cheating or shortcuts will take you nowhere. Trust me. So with this, if I wish to solve this, I'll again use Saras rule. What did he say? Sir, let the determinant just like that only. But if you are simply, just let me remove this part so that it becomes doable. So here I'm just removing this part a little so that we have the space to solve this. I hope you're okay with this. So now what did Sarah say? Sir, Sarah said that repeat the first two rows. Okay. So first two rows means what? X minus 6 minus 1. Second row, 2 minus 3x and x minus 3. Can I be a little quick this time? I hope you are getting more comfortable with this whole idea. So how do I do this? Pay attention, everyone. Sir, this product x minus 3x and x plus 2. I hope you are comfortable with this. So this product, if I take, it is going to be x into minus 3x. What is going to be that? So that is going to be minus 3x square times this x plus 2. Yes or no, everyone? Then the next product which you will take is this 2x and minus 1. So how much is that? So 2 into 2x, 4x into minus 1, that is minus 4x. Comfortably getting it, everyone? Yes or no? Next product, minus 3, 6 and x minus 3. So 6 into 3 is 18. 18 times x minus 3. So can I write it directly? Or if you're getting confused, I'll write it like this, 18 times x minus 3. So this is our first product. From this product, you're supposed to subtract the sum of other products. Do you remember that technique? Yes or no, everyone? Write it in the comments. So with this, I'll find this product. So this product is going to be what? Minus 3 times. So minus will stay there. Minus 9x. So I'll be writing it as minus 9x. Yes or no, everybody? This part if I take, 2x, x minus 3. So 2x into x, 2x square, x minus 3. So I can write it as 2x square times x minus 3. I hope everybody is understanding all of this comfortably. Yes or no? Now, the next thing which I do with this Saras rule is going to be this product. And if I find this product, it will be 2 minus 6 and x plus 2 minus 12. So it will be minus 12 times whole of what? X plus 2. And this expression I'm given as 0. This expression we are given as 0. I hope so far there is no confusion. Yes or no, everybody? Even if you are not participating in this poll with using this Pylens, you can write your answers in the comments. I'll really appreciate that. So far, whatever I've done, is that understood by everyone? Yes or no? Now, how do I solve it further? By simplifying this. So let's do its simplification. So if I now start simplifying it, shall I do it here? Shall I do it here? Is that okay if I do it here? So minus 3x square into x, that's clearly minus 3x cube. Yes or no? Then this is minus 6x square. Yes or no? Then this is clearly minus 4x. Correct me if I do any mistake based on calculation. Minus 3x cube minus 6x square minus 4x, and this will be plus 18x, and this is, I think, 18 into 3. That's clearly 54 and minus 54. Yes. I hope no confusion so far. Everybody with me? Good, Sudarshan. That's brilliant. We'll verify and validate that. And then minus of whole of this. So I'll do this. Pay attention, everyone. Minus 9x, it's negative, will be plus 9x. Then with this, 2x square into x, 2x cube with the negative sign, which means minus 2x cube. Getting it, everyone? Then 2x square into 3, that's minus 6x square. With this minus, it will be plus. So it will be plus 6x square. Then the next thing, minus 12x, but it will make it plus 12x. And the last thing will be minus 24, but it will be plus 24 whole equal to 0. Everybody understood that? Yes or no? Did you all get this, or shall I repeat it? All the participants, be quick. I hope there is no confusion so far regarding all what we have done. Everybody with me so far? Now, what do we do next? I think we simply solve. Good, Vaibhav and Shailesh. That's brilliant. Okay, good. Keep responding. So I think with this, I need to simplify this. So what I'll do is 3x cube, 2x cube. That is minus 5x cube. Correct me if I'm wrong. Then this term with x square and x square is getting cancelled. So I'm getting rid of this. Nothing left with x square. Then with 4x, minus 4x, 18x. That is how much? 14 plus 9 plus 12. I think nothing else is left, right? So 14 plus 12, I think that is 26. 14 plus 12 is 26. 26 plus 9, I think 26 plus 4 is 30 plus 6 is 36. Correct me if I'm wrong. So 26 plus 9. I hope I'm doing it right. Let me correct it. 14 plus 12 is 26. 26 plus 9. I'm really sorry. Did I say 35? 26 plus 9 is 4 plus 5. 35. It will be 35. So it will be 35x. I hope I did not say 36. It is 35x. Correct me if I'm wrong. Then when we talk about the constant terms, so constant terms I think are just 2, 54 and 24. So 24 plus 30 is 54, I believe. So it should be minus 30. So it should be minus 30 is equal to 0. One thing which you all can do is, in order to solve this equation, is simply take 5 common or minus 5. So minus 5 when you take common, it leaves you with x cube minus 7x plus 6 is equal to 0. I hope everybody is realizing it is not a quadratic, it is a cubic, everyone. But if I try and test it with the sum hit and trial approach, I think, which part is wrong, Vaibhav? Can you help me with that? If I try and test it with plus 1, x is equals to plus 1. If I try it with x is equals to plus 1, what is going to be? 1 plus 6, 7 minus 7. So I think plus 1 is satisfying it. I repeat, this equation is satisfied with x is equal to 1. So I hope with remainder theorem and factor theorem, you remember that x minus 1 will be a factor of it. So I can factorize it as x minus 1 into something. If Vaibhav is saying wrong, which part, Vaibhav? Can you be more specific? I'll do it one more time for you. 3 plus 2 is minus 5. 6 and 6 are getting cancelled, so nothing in x square. 18 minus 4 was 14. 14 plus 12 is 26. 26 plus 9 is clearly 30 plus, I hope you're understanding, 35. And then the constant terms, 54 and 24, that was minus 30. I took minus 5 common. X, 7 and 6, of course, with these signs. Now, all I'm saying is I'll get one more expression is equal to 0. Now, how do we do it? Either you do polynomial division. I think I did it. Yes or no? Just give me a second, everyone. But with this, let's say if you're confused, how do I crack this second factor? You can do the basic division. How do we do it? Let's talk about that part now. I hope so far there is no confusion regarding that. Here we are. Shall I do it here? So this part, x cube minus 7x plus 6. You can do with this polynomial division as well, but I am really suggesting you to not do it. Why? I am saying you to do it with your intuition. What do you mean by intuition, sir? This is x cube. This is x. I am looking for a number which when multiplied with this x generates x cube. Why would it not be x square? Because x square into x will be x cube, but x square into 1 will be minus x square. Sir, this minus x square was not supposed to be there, indeed. So let me get rid of this minus x square. How? So to get rid of this minus x square, I think I should, I hope you're realizing, multiply it with minus x. I repeat, if I multiply a minus x with this x, minus x into x will give me minus, sorry, I need plus. So if I put a plus x, that x into x will give me plus x square, and they will get cancelled, and I will not get a term in x square. So I'm trying to think based on my intuition of these terms so that I can get this result. Yes or no? Now the next thing, pay attention everyone. Sir, okay, you multiply x with x, you got it, but you got to multiply this x with minus 1. Yes, so x with minus 1 gives you a minus x here. But sir, were you not supposed to get minus 7x? You are getting minus x. So I think in order to get minus 7x with this minus x, all I need is minus 6x. How do I generate minus 6x? I think minus 6x can be generated with a minus 6. How? Because minus 6 into x will be minus 6x. But with this, I hope everybody is very clearly realizing that minus 6 into minus 1 will be plus 6. So I think with this intuition-based method also, we are able to generate it. Was it really difficult? Were you all able to understand this? Yes or no? All the participants. So I think you have gotten a decent idea. How did we crack the second factor? So with this, if we are able to generate all of this, I think I'm very close to my final answer with this idea that this whole determinant gets boiled down to this. There, I hope. Real solutions, if somebody was talking about, x we receive as 1. And second, from this, so let's check its discriminant. Its discriminant, if I check, it is going to be b square, which is 1, minus 4ac. So 6 into 4 is what? 6 into 4 is 24. So I think it is solvable. And if it can be solved, I hope you remember it very basically and clearly. So product we want to be minus 6. Sum should be plus 1. I think 3 and minus 2 will do the justice. So this part stays sorted like x minus 1. But if I wish to simplify this, x squared plus 3x minus 2x minus 6 is equal to 0. So from here, the solutions are going to be, I hope you're noticing, minus 3 and plus 2. So few more solutions are going to be minus 3 and plus 2. Everybody got that? Now, what are we asked? Sum of the real roots. Sir, why did you not find the answer from here only, from this equation only? Because I hope you remember, in theory of equations, in class 11th, the chapter has told us that if this is an equation which has roots alpha, beta, and gamma, because this is a cubic, so sum of the roots alpha plus beta plus gamma is given by minus b by a. Minus b means coefficient of x square with its negative sign. So that would be 0 by 1, of course. But the whole idea is this method is absolutely correct, but not applicable in this question because the whole problem is, yes, I am asked the real roots. This equation, I don't know whether it can be solved or not, or whether it has real roots or not. So this alpha plus beta plus gamma gives you the sum of the roots, whether real or imaginary or complex. I needed to find the actual roots, the real roots, and once I have found the real roots, then I was supposed to do the sum. So 3 minus 3, the answer is 0, and that's where I'll say the answer is going to be 0 to this question. So I'm sure now everybody must have done with this whole correct approach only, and some of you must have done with this right idea or right method only, and with this, I am sure the correct answer to this question would have been option A. How many of you sincerely did it with their genuine efforts? Okay, so Sudarshan, Sailesh, and Bhairav, that's brilliant, that's excellent. And I'm sure you're doing it with your sincere and genuine efforts, but with this excellent, good, great, really nice. Shall I move ahead from here? All the participants, shall I move towards few more things? Everybody, watch it with complete attention and focus. Now, I'm going to explain you the concept of symmetric and skew-symmetric. Pay attention, everyone. If I could tell you what is symmetric and skew-symmetric, let's focus on a determinant. Although this is a concept which we'll study with the chapter matrices, but right now in this chapter determinants, we'll be using it because determinant and matrices are interrelated, which means with the determinant and matrices, you will see at least 2 to 3 questions in this mains examination in any random shift. 2 to 3 questions. A question carries 4 marks. 3 questions will carry 12 marks. 12 marks in mathematics section is something phenomenal, unbelievable, and exceptional. 12 marks give you a huge difference in JEE Mains if you're scoring it from mathematics section. And that all is given by this combination of matrices and determinant, which is a one single unit. I hope you're understanding this importance, what a lethal combination it is. So there I'm saying with the determinant, in the next video of this series, we'll be covering matrices. With the 2 videos, you are tending towards that plus 12 in JEE Mains from mathematics section. Can you believe that? That's the whole idea. Now, if I tell you that matrices and determinants are interrelated, few things we'll be covering in matrices, which we might be using today. So I'll give you a glimpse of them. What are the glimpse? Let's say there is a matrix A. Matrix is technically an arrangement of rows and columns. With this, let's say if I have elements like 2, 3, let's say if I have elements like, randomly I'm writing it as 2, 5, 7, then 3, 3, 8, 8, -6 and -6. Now, sir, why have you taken it like this? I'll tell you, have patience. If I take its transpose, sir, we were still not very much done with the terms like minors and cofactors. Now you have introduced another term, transpose. What is transpose? So transpose in the world of matrices means that you interchange rows with columns. What does it mean? It means rows of this become the columns, or vice versa, columns of this becomes the rows, which means, what is the first column? Sir, first column is 2, 3, 8. Make it the first row. So 2, then 3, then 8. Okay. Then the next, 3, 5, -6. That's your second column. Make it the second row. So 3, 5, and -6. Then take the third column, 8, -6, and 7. Make it the third row. So 8, -6, and 7. Now, sir, what do you mean by all of this? Why are you doing all this? Have patience. If you are paying some attention, are you not noticing that, sir, A and A transpose as matrices look same because they were having the same order 3 by 3. This had 3 rows, 3 columns. This also has 3 rows and 3 columns. Not just that, the element positioned at first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column, third row, first column, third row, second column, third row, third column. They are absolutely same. They are absolutely identical. Yes or no, everyone? Yes or no, everyone? Which means what? Which means that here, if there was a matrix given to us, and if I found its transpose, luckily or coincidentally, I found that matrix and its transpose to be same. I found that matrix and its transpose to be same. So if you ever see a matrix and its transpose to be same, if you ever find a matrix and its transpose to be same, you claim that that matrix is a symmetric matrix. That matrix is a symmetric matrix. Getting my point, everyone? Yes or no? Now with this, one more thing you got to remember is, let's say I am dealing with a matrix B for a while. B matrix is again a 3 by 3 matrix, which means 3 rows, 3 columns. It has elements like 0, 2, 3, then let's say -2, 0, 5. Then you have, let's say, -3, -5, and 0. Now, can you help me in finding its transpose? Now you're very much comfortable with this whole process or whole idea. So if I find the transpose here, what will you say? Sir, it's simply nothing but change the rows into columns, interchange the rows in columns. Excellent, Khushi. So with this first column, 0, -2, -3 becomes our first row, 0, -2, -3. Second column, 2, 0, -5 becomes second row. So this is 2, 0, -5. third column 350 becomes our third row 350. Shall I tell you one thing very interesting? With matrices, you can take something common from all the elements. What did I just say? I said that here, from this, I can take -1 common from all the elements with matrices. I did not say determinants. So let's say if I'm taking -1 common, if I'm taking -1 common, so -1 taken common from here will give you 0, -1 taken common from here will give you 2, -1 taken common from here will give you 3, -1 from here will make it -2, -1 from here will keep it 0, -1 from here will make it 5. -1 from here will make it -3, -1 from here will make it -5, -1 from here will make it 0. Sir, why are you doing all this? Why are we really doing all this? What is the point of doing all of this? I think some of you might have noticed, some of you may not have. Let me tell you. 0, 2, 3, -2, 0, 5, -3, -5, 0. 0, 2, 3, -2, 0, 5, -3, -5, 0. I think this and this are identical. So I have gotten -b. What did I just say? I said two things. Previously, when I found the transpose of a matrix to be equal to it, I called it to be a symmetric. Absolutely stylish. Anna. But if I talk about this part, here what did I do? Sir, I found the transpose of B, but luckily I did not find it equal to B. Had it been like that, I would have called it symmetric. But in this case, transpose of B is found to be negative of B. In that case, we call it skew-symmetric matrix. Yes or no, everyone? Yes or no, everyone? Yes or no? Everybody getting it? Everybody understanding it? And with this, I hope now you are in a very clear position to claim that it is a skew-symmetric. But along with this, I wanted you all to understand few more things very clearly. What are those things? Let's talk about them. Those things are these where when you talk about symmetric, are you not noticing something very interesting? Sir, this you claimed to be symmetric? Yes. So there was nothing special about the principal diagonal elements, but this 3 and this 3 were same. This -6 and this -6 were same. This 8 and this 8 were same. Are you noticing something interesting here? Sir, when you talked about skew-symmetric matrix, what was special about skew-symmetric matrix? Sir, with skew-symmetric matrix, principal diagonal elements remained 0, but this 2 and this 2 were same in terms of magnitude but opposite in sign. This -3 and this 3 were same in terms of magnitude but opposite in sign. This -5 and 5 were same in terms of magnitude but opposite in sign. Everybody developing the logic for skew-symmetric and symmetric. Are you able to see the mirrors? Yes or no? So the image of symmetric and skew-symmetric is that getting stored in your brain? Yes or no? I hope everybody is now comfortable with that. So if you are all comfortable with that idea, I am trying to tell you that if in a determinant Aij is equals to -Aji, sir, what have you started discussing all of a sudden? So far we were understanding everything and now you bring something really different. Aij, Agi, what is that? Have patience. All I'm saying is that here there is a matrix. This is A11, A12, A13. This is A21, A22, A23. This is A31, A32, A33. Now I'm giving you the third definition of a skew-symmetric, which is basically an extension of the previous definition only. All I'm saying is that here, if A12 is equal to A21 but with a negative sign, A13 is equal to A31 but with a negative sign, A23 is equal to A32 but with a negative sign. So this should be true for all the elements. Yes, I am also saying that. Which means here A11 should be equal to -A11. Now try and think logically. There is a number which is equal to its negative. Is that really possible? Except for 0, it is not true. If a number is equal to its negative, that happens only when it is 0. So I hope you're realizing these principal diagonal elements, if A11 is equals to minus A11, A22 is minus A22, A33 is equal to minus A33, it will be true only when A11, A22, A33, they all are 0. So the whole broader or clearer picture of a skew-symmetric matrix will be like this. Principal diagonal elements will always be 0, as most of you have already highlighted. Good, Salish. And the other element will be pairwise, same in magnitude, but opposite in sign. The whole idea which I am trying to bring here is this simple fact that if you ever see a skew-symmetric matrix, then don't hesitate in writing the value of that matrix, the determinant, as 0 if it is an odd order matrix, odd order determinant. I repeat, if it is a 3 by 3 determinant, 3 by 3, 3 by 3, odd, that too skew, then even without expanding it, you can always unhesitatingly say that its determinant is always going to be 0. Will you all remember that? Congratulations, Sonali. We are really proud of you. Keep it up. So everybody understood this whole idea? Did you have idli today? We'll always remember you like this. Not even with Sarah's rule, I hope you will remember it as a fact. What is the fact? That value of skew-symmetric determinant of odd order is always 0. JEE indeed has asked questions on it, directly or indirectly, and I'll be really happy if you remember this property and apply it directly in the question without even expanding it. Great. That's great. That's excellent. With this, now, shall we move towards the next idea, next concept? If you all are comfortable with whatever is said so far, let's talk about this result here. So, this result says ABC, not all are equal. They are not all are equal, okay, and they are positive. And I need to prove that the value of this determinant is negative. How do we do that? Let's do it. Everyone paying attention? Sir, we know the expansion of determinant. Can we do it with Saras now? I hope you're getting this feeling, because Saras is such an easy rule, such an easy, simple method, such a handy method, more convenient, I think it is. So if I again use Saras, what did Saras say? Sir, repeat the first two rows. So A, B, C, B, C, A, yes or no? With this, I hope you're now more comfortable. What do we do next? Sir, multiply these three. That's A, B, C. I am denoting it by delta, so this is the value of this determinant delta. Then multiply these three, that's again A, B, C. Then multiply these three, that's again what? Nothing but A, B, C. Remember that, everyone? Absolutely. Thank you so much for confirming it. Now with this, I'll multiply this. So from this sum, I'll subtract the sum of other product. C, that's C cube. Then A, that's A cube, and B, that's clearly B cube. I hope so far there is no confusion. If I now simplify this, how will I do it? Pay attention, everyone. A cube, B cube, C cube. If I take the negative sign common out of it, I'm left with A cube plus B cube plus C cube. 3ABC, but with a negative sign, because I have taken negative sign common out of it. This is 3ABC. Can somebody make me recall this? Have we not studied it infinitely many times? You may be watching it for the first time, but if you watch our previous lectures, we have discussed this particular identity infinitely many times. And I have been clearly and constantly mentioning it that IIT JEE is in madly love with this particular identity. This A cube plus B cube plus C cube minus 3ABC. Can somebody in the comments write the identity that A cube plus B cube plus C cube minus 3ABC we write as? Somebody in the comments, please. All those who are sincerely watching it, quickly, be quick. I hope some of you must have remembered this A cube plus B cube plus C cube minus 3ABC, yes, cyclic it is, can always be written as A plus B plus C times whole of A square plus b square plus c square minus ab minus bc minus ca. Do you all remember that? Do you all remember that? Some of you must have already remembered that. This is what we have discussed a lot many times. Now, sir, what is the point of discussing all this? Have patience. I'll do it in the next step. If I multiply this whole expression by 2 and divide it by 2, will I get something? Let's see. So if I multiply and divide this whole expression by 2, this still remains minus 1 only. Nothing changes. But what is the advantage of doing this? Let's talk about that. Have patience and just keep watching. Something really good will happen now if you are paying attention. Sir, what is that? Okay, we are discussing about that only. Have patience. So I am pushing this 2 inside. So here, the outer part stays like minus 1 by 2. Whole of this, which is a plus b plus c times this 2, if gets multiplied to all of these terms. Great, Shailesh. That's brilliant. That's brilliant. Good, good, Khushi. That's good. I'm seeing the comments now. That's good. So with this 2 is pushed inside. So it is 2a square plus 2b square plus 2c square minus 2ab minus 2bc and minus 2ca. Yes or no? Everybody, give me a quick response. And with this, I am sure some of you might have already noticed that, sir, if I snatch 1a square, 1b square and 1 minus 2ab from here, it will be written as a minus b whole square. Can I do so? This is 2a square. I write it as a square plus a square. This is 2b square. I write it as b square plus b square. So 1a square clubbed with 1b square with minus 2ab. So a square plus b square minus 2ab. Can that not be written as a minus b whole square? Yes or no? With this, I hope you are noticing it. It's expanded version if I write here. I write it here so that it becomes understandable. It is technically a square plus b square plus b square plus c square minus 2ab minus 2bc minus 2ca. So there all I'm saying is that all I have done is a square plus b square minus 2ab. I have written it as a minus b square. I hope you can do this. Absolutely, Jon Snow. With this, if I now do one more thing, which things are b square plus c square minus 2bc, will that not be written as b minus c whole square? Yes or no, everybody? Diya, it does not happen like that. I hope you know this. The very basic concept of maths you are asking me. Let's say 2 into 3 into 5 you are doing. So you don't multiply it as 2 into 3 into 2 into 5. No, this is wrong mathematically. You know that, right? You're not asking me this here. But I hope if you want to do it, you can write it like what? 3 into 2 into 5. So this is how you do it. And this is exactly what I've done. What you might be thinking here is that let's say 2 is multiplied with 3 plus 5. There you do it as 2 into 3 plus 2 into 5. So that concept, please don't misuse here. I hope you got my point. Shall I come back to the whole discussion? Now the third thing which I'll do here is c square plus a square minus 2ca. So that will be c minus a whole square. Everybody got this? And outside we have a plus b plus c whole times negative half. So far, tell me honestly, whatever I have done, is that understood by everyone? Whatever I have done, is that understood by everyone? Now you answer few things, few questions of mine. If you all can, I'll be really happy. I was told that A, B and C all are positive and not all are equal, which means A minus B or B minus C or C minus A cannot be 0 because they are not equal. And if they cannot be 0, they can be either positive or negative. Whether positive or negative, when they are squared, something non-zero, whether negative or positive, if it is squared, will it not be positive? So I hope you're realizing this a minus b whole square will always be positive, not even 0 because they are not equal. B minus c whole square will also positive. C minus A square will also be positive. I ruined the hairstyle of this guy. So positive plus positive plus positive, will I not say, is positive. So 1 by 2 times A plus B plus C into something always positive. I hope my language is very clearly understood by everyone. This whole bracket is technically always positive. Yes or no, everyone? So far, everyone comfortable with this whole idea? Now, A, B, C, they all were positive. So this A plus B plus C is also going to be always positive. So positive into positive into positive into negative. So one negative will make it all negative. So I think I have proved it that this determinant was supposed to be proven negative. So this proof-based questions will not be asked in JEE. But trust me, the whole concept which we applied here, based on this concept, questions will be asked in JEE. Something very important I wish to highlight, so don't forget this. I am keeping it highlighted here. A very important fact here, which I want you all to remember as a fact. What am I trying to say you here is a cube plus b cube plus c cube minus 3abc has two versions. First version, please remember, it is given by a plus b plus c times a square plus b square plus c square minus AB minus BC minus CA, as we have just used. The other version, half of A plus B plus C times whole of A minus B square plus B minus C whole square plus C minus A whole square. Now, although I have proved it in this question, you really don't have to. You really don't have to. So next time, when you see a question like this, you don't waste your time in deriving it like this. You directly get the answer. You directly write the step, this step. One more very important, very, very decisive conclusion I want to give you here is that if you ever see you are given three numbers whose sum is 0. If you are ever given three numbers whose sum is 0, can you tell me what will be sum of their cubes? What will be the sum of their cubes? If you ever encounter three numbers whose sum is 0, what will be the sum of their cubes? Sir, if A plus B plus C is 0, so 0 into anything is 0, which means A cube plus B cube plus C cube minus 3ABC is 0, which means A cube plus B cube plus C cube is 3ABC. I hope no confusion so far. For example, just to make you understand this, let's say I take A as 11, B as 22, and C as minus 33. And that's good, Khushi, Shubhrankal Zunkar. That's good, Shailesh. Now, if I ask you 11 square plus 22 square plus minus 33 square, I hope, sorry, not square, cube, 11 cube plus 22 cube minus 33 cube. So, as an intelligent student, if you have noticed, 11 plus 22 is 33, 33 minus 33 is 0. So you will say that's an answer to this question you cannot or you should not attain by using this 11 cube plus 22 cube minus 33 cube. You don't have to really calculate all of this. You can directly say the answer is going to be 3 A, B, C. And I think calculating this is a little easier. And that will be your answer. Little stars, I'll do it in the end. Cramer's rule will cover in the end. So have patience. Is that okay? So I hope this whole idea is very well understood by you all. And I'm sure you are going to remember it. You wouldn't forget it. This is something which is very critical and useful for IDG. This result, it's two versions, this whole idea. Please remember that. And I'm sure you wouldn't forget it now. Yes or no? With this, shall I move ahead from here, all the participants? So with this, shall I give you this question as a homework now? Will you try this at home? So, how are we going to have this PDF? Absolutely, you can. How? This entire PDF will be uploaded on our WhatsApp channel. Yes, this whole PDF will get uploaded on our WhatsApp channel. Sir, where is your WhatsApp channel? How do we find it? So to follow our WhatsApp channel, the link you can check in the description of this video. There you'll find the description. The link is given. You can follow our channel, and after this session, the entire determinants one shot will get uploaded on our WhatsApp channel. And by having that PDF, you can solve this question by yourself. Will you all? Great, excellent. So this question I'm giving you as a homework question, but definitely when you start doing it, you can utilize this hint if you want. What is the hint? What are we asked? We are asked find the number of real roots of this equation where I'm told A, B, C are real. Hint is really simple. Use Sarah's rule for expansion. If you simply use Sarah's rule for expansion, trust me, you will very easily be done with this question. So will you all try this question by yourself? Shall I give you this question as a homework question? Is that okay? So after this question, if I move ahead, we now move towards elementary properties of determinants. So now we'll be discussing it. Since it's already some decent time we have covered, let's take a 10 minutes break and then we'll resume. Is that okay? So 10 minutes break we are taking. We'll resume after 10 minutes break. So we will resume this class at we'll resume this class at around 9:45 or around 9:45 approximately. So 10 minutes break. Definitely I'll do that. Don't worry. After this part, I'm coming to that part as well. Don't worry. I'll do that. Take a 10 minutes break, hydrate yourself, stretch yourself, and then we'll be back. Is that okay? 10 minutes. Okay. Welcome back, everyone. If you are seeing the screen, if the screen is there in front of you, or if you can hear my voice, come back, everyone. We are resuming our discussion. So I hope I'm clearly visible and audible. You can hear me. And come back, everyone. Those who are watching it live, come back, come back, come back. Great. Shall we get started with our discussion now? Are you all there? Come back, everyone. I hope the break is over. You have hydrated yourself. You have stretched yourself, and now you're again back in front of your lecture. Shall we get started? Good, great, perfect, brilliant. What are we told here? We are told that consider the determinant. So this is the determinant A1, B1, C1, A2, B2, C2, and A3, B3, C3. Now, what am I supposed to do? Pay attention, everyone. We'll be discussing a lot of properties. Sir, why properties? Determinant was alone not enough. I am saying yes, it was, but if you know some properties, you can solve questions based on determinants more easily, more quickly. But one thing you should always remember, whether you remember these properties or not, that Sarah's rule, if you remember, you will be doing a lot of justice to the questions very quickly. But still, if you want to learn these properties and get comfortable with them, here they are. The first property. I think you have already seen this, haven't you? Pay attention, everyone. The first property. Transposing a determinant, that is shifting all the rows to corresponding columns or shifting all the columns to corresponding rows, does not change the value of the determinant. What did I just say? Do you remember this determinant here? Do you all remember this determinant here? What was this determinant? Delta. So what will be its transpose? Its transpose will be changing its rows into columns. So A1, B1, C1, first row becomes first column. A2, B2, C2, second row becomes second column. And A3, B3, C3, the third row becomes third column, which is A3, B3, C3. Trust me, the transpose when you did will have the same value, which means whether you find delta by expanding this determinant or you find delta t, which is the transpose of it, it will have the same value. No matter what is the order of the determinant, that's a property. Will you all remember it? Tell me in the comments quickly, yes or no, everyone. I repeat, whether you find delta or delta t, it is always going to be same. Everybody understood that? Everybody got that conclusion? Will you all remember it? So a determinant or its transpose will have the same value always. If I could take a very simple example just to make you understand this, let's say there is 2, 3, 5, 6. It's a determinant. And what will its transpose look like? Sir, its transpose will be 2, 3, first column, 5, 6, second column. Now, whether you find the determinant here 2 into 6, that's 12, 5 into 3, that's 15, or the determinant here 2 into 6, that's 12, 5 into 3, that's 15. Are you not realizing they are same? Although I've taken an example, a numerical one, but algebraically also you can prove it. But I hope you got the whole idea that why is it true? Everyone understood that? Shall I move ahead from here? The next property, shall we discuss that? I think no confusion regarding this. No confusion regarding this. Will you all remember that? Now the second thing, this question, can you solve this? Glad to be something like that in your life. Let's try and solve this question. And that's what JEE does. Although this is a proof-based questions, but it will directly help you in solving questions based off JEE. So now, I am told that this determinant, I am told to find out that this determinant is real. So one of the matrices, I really expand it. And after its expansion, I find out its value. And are you not realizing, sir, expansion of a determinant is already tricky? And you are asking us to expand a determinant which has complex entries in it. Are you not thinking it will be way huge, way lengthy, unnecessarily lengthy? How are we going to solve this with some shorter approach? Is there any idea or a better shot? Yes. How? Let's look that. So I am asked to prove that its value is real. Or let's say, what if I am asked to find out its value? Exactly. Good, Manthan. So with this, if I denote it by delta for a while, so I'm calling it delta. Can somebody tell me its transpose? So sir, its transpose is going to be delta t, which will be what? Which will be, let's say I'm denoting it as a matrix A and I'm calling it a matrix for a while. Can I do so? If you are okay with that, I hope I can call it like this. Everyone fine and okay with this? So I'm treating it as a matrix A, which is of course a 3 by 3 matrix, which has complex entries in it. Everyone getting that? Now with this, if I ask you to find the transpose of A, can you help me in finding the transpose of A, students? How do we find the transpose of A? Sir, rows and columns interchanged. So first row, minus 7, 5 plus 3 iota, 2 by 3 minus 4. So this becomes minus 7. This becomes 5 plus 3 iota here, and that becomes 2 by 3 minus 4 iota. Yes or no? I hope I have written it correctly. Minus 7, 5 plus 3 iota, 2 minus 4 iota. Yes or no, everyone? Then here, second row becomes the second column. So this is your 5 minus 3 iota. This here is 8. And this here is 4 plus 5 iota. Everyone comfortably getting this? Now, third row got converted into third column. So third row is 2 by 3 plus 4 iota, next 4 minus 5 iota, and next 9. Sir, why are we doing all of this? First of all, you answer one question of mine. I hope you are understanding. Determinant of this matrix A or determinant of this matrix A transpose, will it not be same? So determinant of A and determinant of A transpose is going to be same. Indeed, it is going to be same. We know that. We have just discussed a property that whether you take transpose of this matrix, which is this, and take the determinant of this matrix or this matrix, it will be same. Remember that fact, that property. But sir, how is it useful here? Let me complete my point. How is it useful? I hope you remember one thing very clearly, that conjugate. I'm going back to the complex numbers world. So in the world of complex numbers, you must have seen something like this. If z is a complex number given by x plus iota y, how do we find out its conjugate? Sir, conjugate is simply nothing, but you change the sign of its imaginary part. The sign of its imaginary part is changed. So Shar is asking, sir, I'm great. Thank you so much for being so considerate. No worries. Let's stay focused, everyone. So this is a complex number. This is its conjugate, which means you simply change the sign of its imaginary part. And conjugate is such a beautiful property that it can be distributed over addition, subtraction, multiplication, or product. Not just that, over determinants as well, and matrices too. Which means if I ask you to find out the conjugate of A is technically a matrix, but if I find out its determinant, it will be a number, a complex number, because it will be expanded. It has complex entries. So if I wish to find out its conjugate, that conjugate can be found by simply taking conjugate of every single term. Did you hear me? What did I just say? I repeat my statement. So this is A, and if you take its conjugate, let me write the conjugate of A. So conjugate of A is denoted by AC or A bar, like that. So if I'm taking the conjugate of A, which I'm denoting by A bar. So I hope you remember conjugate means what? Conjugate of every single element. So minus 7 is purely real. It will remain like that only. Then 5 plus 3 iota, its conjugate will be 5 minus 3 iota. Yes or no? Then 2 by 3 minus 4 iota, its conjugate will be 2 by 3 plus 4 iota. Are you all noticing something very interesting? With this 5 minus 3 iota, sir, its conjugate will be 5 plus 3 iota. 8 is purely real. Its conjugate will be plus 8. 4 plus 5 iota, its conjugate will be 4 minus 5 iota. I hope you're understanding this concept more clearly now. 2 by 3 plus 4 iota, its conjugate will be 2 by 3 minus 4 iota. 4 minus 5 iota, its conjugate will be 4 plus 5 iota. And the last thing, 9, purely real, its conjugate will be plus 9. Everybody got that? Everybody comfortable with whatever I've done so far? What did I just do? I did nothing except for one thing, that here, this was your original matrix A. I took its conjugate. How do we take the conjugate? I took conjugate of every single element. Conjugate means changing the sign of the imaginary part. So this is how the conjugate looks like. But I am asking you to tell me that if you match this conjugate with its transpose, are they not looking same? Look at this A transpose. Look at this A transpose. Look at this A transpose. And look at this conjugate. Are you all not noticing something really simple and straightforward, that A transpose here and conjugate of A are absolutely same? Now, one thing we have discovered so far was if somebody tells you that A transpose and conjugate of A are same, yes or no? But sir, we know one more thing, that determinant of A and determinant of A transpose will be same. We have just learned this property, haven't we? We did discuss that whether you have a matrix or its transpose, their determinant will be same. But sir, you have proved one more thing in this question. What is that property? Sir, conjugate of this matrix here and this determinants transpose, this matrix transpose are same. So if two matrices are same, their determinants will be same. So from here, am I not concluding that determinant of A transpose and determinant of A conjugate are same? I hope I'm not confusing anyone and you are able to digest and understand my language. Yes or no? So all I'm saying is that from this and this, if I club this, I hope you can see the common entity is A transpose. The common entity is A transpose. So what I am simply saying is determinant of A and determinant of A conjugate is same. A transpose, if its determinant is equal to this and this, so this and this should also be equal. Basic idea. So if I club this data, I am reaching to a very beautiful and important conclusion that determinant of this matrix A or conjugate of this determinant of conjugate of this matrix A are same. Yes or no? Yes or no? Yes or no? So with this, my final conclusion is really simple. I hope some of you have gotten it. If I get back to the discussion of complex numbers, I think some of you would tell me that if somebody claims that there is a complex number and there is a conjugate of this complex number and they are said to be same, they are said to be same, they are said to be same. In that case, I hope you remember, if x plus iota y is said to be equal to x minus iota y, x and x are cancelled, 2 iota y is 0, which leads to y being 0. Y is 0 means y is 0. Y means imaginary part is 0. So if in a complex number, imaginary part is 0, we say that that complex number is purely real complex number. Do you remember that? Do you remember that? This is what you must have studied in 11th standard when you have gone through the chapter complex numbers, that if z minus z bar is 0 or if z is equals to z bar, we claim z is a purely real complex number. That idea, if I apply here in this question, I think I am reaching to a conclusion that I have now finally been able to conclude that, sir, this, let's say when expanded as a determinant, leads to a complex number. Yes or no? So this whole, if its determinant, if the determinant of A, if I denote by Z, I hope its conjugate's determinant will be denoted by Z bar. And luckily, what did I find? I found that determinant of A and determinant of A conjugate was same, which means I could conclude that Z and Z bar are same. And the moment somebody says that a complex number and its conjugate are same, in that case, this is true only when that complex number is purely real. And I think that's exactly what we are supposed to prove, that this determinant is purely real. Everybody understood the whole explanation. Everybody got that. Or shall I re-explain this? Every single thing which I've done in this question, I begin with this complex number, rather a determinant, which will be expanded as a complex number because it has entries to be complex. But sir, when you take its transpose, its determinant will be same, because we know whether you take the determinant or its transpose, it is always same in terms of determinant, yes or no. Not just that, when I took the conjugate of it, it was equal to its transpose. So I reached to a conclusion that they are same. They means the complex number and its conjugate. And if they are equal, I need not tell you that complex number is purely real. Yes or no? Everybody remember that? Everybody. So I hope the whole explanation was understood by everyone. Yes or no? Or shall I re-explain this part? Give me a quick update. Give me a quick update. Everyone comfortably got all of what I've said so far or explained so far? Great, perfect, brilliant. With this, let's talk about the next property. Pay attention, everyone. Interchanging two rows or two columns give you the negative of that determinant. What did I just say? Let's say here, the first row was A1, B1, C1. Second row was A2, B2, C2 in original delta. I hope you remember the original delta A1, B1, C1, A2, B2, C2, A3, B3, C3. But in that delta, if I swap the first row and second row, if I interchange the first row by second row, I hope you're understanding that operation is denoted by row 1 swapped with row 2, row 1 interchanged with row 2. So when a row is interchanged by a row or when a column is interchanged by a column, with that operation, a negative sign comes to the front of that value of that determinant. Sir, what are you trying to say? We are not able to get it. I am saying, let's say, let's say there is a determinant delta which has entries like 2, 3, 7, -1, 0, 5, 4, 6, 2. It will have a value. Let's not find its value. Let's say its value is delta. You can find out by its expansion. What if I interchange two rows? Let's say I have interchanged row 1 with row 3. I have interchanged row 1 with row 3. So when you interchange row 1 with row 3, this second row remains intact, -1, 0, 5. But row 3 becomes first row, 4, 6, 2. Row 1 becomes third row, 2, 3, and 7. With this, what happens here is very clearly nothing, but this will be delta only with a negative sign. That's it. So if you have found the value of this determinant, you really don't have to find the value of this determinant. It will be in terms of magnitude same, but with a negative sign. Shall I tell you one more fact? Tell me whether you're able to digest it or not. Let's say this interchanging of row, I apply even number of times. Will it not give me plus delta? If this interchanging of row, I apply odd number of times, will it not give me minus delta? Sir did not get it. I knew it. I'll explain it with an example. Let's say this I have done once. I'm doing it one more time. This time I'm interchanging row 2 with row 3. So when you do this now, when you're doing row 2 with row 3, so first row remains intact. So it will be 4, 6, 2. Then row 2 and row 2 are interchanged. So -1, 0, 5 will become our third row and 2, 3, 7 will become our second row. Yes or no? Getting it or not, everyone? So now what will be the value of this? Sir, you have interchanged a row. Yes. So this determinant had a value minus delta. Yes. So when you interchange a row by row or a column by column, a negative sign comes into picture. And with this, negative of negative is positive. Everybody got my point, or shall I repeat it? All I am saying is simply nothing. But now what I've done is I have performed interchanging of row even number of times. Twice I have done it. First time I did it here. Second time I did it here. So 2 times I have done it. And if I have done it twice, I hope you are noticing it became positive of delta. But if I was doing it only once, it was negative of delta. Did you understand the gravity of my statement now? Shall I repeat it? This interchanging of rows by rows or column by column, if you are doing it even number of times, it remains plus delta. But if you are doing it odd number of times, let's say only once, it becomes negative of delta. Got it or not? Everyone, tell me quickly, all the participants. Shall I get back to this discussion now? Everyone comfortably understood this property that, sir, interchanging of row and column is allowed, row by row or column by column. But if that interchanging is done even number of times, it remains delta only. But if it's done odd number of times, it becomes minus delta. Comfortable, everyone? So far, there is no confusion. All I'm saying is, remember this result. Will you all, yes or no? Now the next property. This is a very beautiful property and a very interesting property, and let's learn how do we apply it in the questions, shall we? Pay attention, everyone. Let's say there is a determinant which is denoted by delta. It has again certain entries 2, 3, 4, -1, 7, 6, 5, 0, 2. That's your delta. Let's say, sir, I want to multiply as per the need of the question any row or any column by a certain value. Can we do so? Yes, we can. But sir, can we really do it? We can, but with a slight change. Let me denote that operation first of all. That operation goes like this. Let's say I want to multiply row 2 by 3 times. So I'm making this operation here. I'm updating second row by thrice of its elements. Can we do that? You can, but the problem is, the whole problem is that its value, the value of the determinant will also get tripled. I repeat my statement. If you ever wish to multiply any row or any column of a determinant by a certain value, then the value of the determinant gets also multiplied by that value. Which means here, let's say on the RHS, row 2 is getting updated by 3 times of row 2. So first row remains 2, 3, 4. Third row remains 5, 0, 2. And here, second row will become -1 into 3, that's -3. 7 into 3, that's 21. And 6 into 3, that's 18. Now, if somebody asks you the value of this determinant, you really don't have to find it. Did you not find the value of this determinant? By expansion, you can. Let's say that is delta, that comes out as delta. So here, triple of delta is going to be 3 delta. Sir, why did it turn out as 3 delta? Because with the 3 delta, it will be 3 times of row 2 or vice versa. If any row or any column is multiplied by a scalar quantity, that the value of that determinant also gets multiplied by that scalar quantity. Tell me in the comment box, everyone, be quick. Did you all understand this? Will you all remember this basic standard decent property? I hope no confusion on that. So, sir, does it not mean that it has a corollary here? What is the corollary here? Let me tell you that corollary as well. Let's say, as per the need of the question, I wish to multiply third column by a fixed value. Can I? I can. But to keep it balanced, I got to divide it as well. I repeat, with the determinants, you can multiply any row or any column by a number. But to keep it same as the original determinant, you got to divide as well. Shall I repeat that? Shall I repeat that, everyone? I'm repeating it. Pay attention, everyone. Pay attention, everyone. Just hold on for a while, students. Let me just fix this. Everybody. Pay attention, everyone. Pay attention, everyone. Let's say this is your delta, which is 2, 3, 4, -1, 7, 6. And the next thing is 5, 0, 2. Yes or no, everybody? If I multiplied by 1, is that okay? Is that fine? Yes, it is absolutely fine. Multiplying it by 1 will not create any problem at all. So 1, can it not be written as, let's say for a while, 7 by 7? So what did I just say? Sir, we want to multiply the third column by 7. So all I'm saying is that this 7 can be pushed inside, but this 1 by 7 has to stay outside so that it remains balanced. So that 7 I can multiply here to any row and any column and it will still remain same. That's the beauty of the properties of determinants, which means if you ever expand this determinant, and get its value and divide it by 7, it will still remain this delta only. Trust me. Got my point? I hope that property is very well understood by everyone. Shall I talk about the next property? Everyone give me a quick thumbs up and update. Everyone got this property? That's exactly what is written over here. Pay attention, everyone. If you are updating any row or any column by some scalar quantity times that, then in that case, that determinant, the new determinant, let's say rho 1 is getting multiplied by a scalar quantity m. Rho 1 has gotten multiplied by a scalar quantity m. In that case, just remember this as a fact that this delta 3 is nothing but m times delta 1. M times delta 1. I'll write it there only so that it remains understandable. This is written in terms of words here, but let me explain this more clearly. This is delta 3, which is nothing but m times delta 1. Sir, why? Because I multiplied the first row by a scalar quantity m. So the value of the whole determinant gets also multiplied by this scalar quantity m. Everybody got this, or shall I re-explain this? All the participants, be quick. Understood? Yes or no? With this, if I move ahead with or towards the next property, what does it say? This is the most important, the most crucial, or one of the most crucial properties. What does it say? Pay attention, everyone. It says, let's say if I'm given a determinant like this. Like this means what? Its second row and second column are simply A2, B2, C2, A3, B3, C3. But in the first row, I am seeing the elements to be splitted like this. Splitted like this means A1, A1 dash, B1 plus B1 dash, C1 plus C1 dash. So the beauty of determinant says that you can split this determinant as a sum of two determinants. Sir, which kind of two determinants? Those two determinants are going to be A1, A2, A3, B1, B2, B3, C1, C2, C3 plus A1 dash A2, A3, B1 dash B2, B3, C1 dash C2, C3. Yes or no? Yes or no? Or shall I repeat that? All the participants. Let me take an example. Let's say there we have a matrix, or let's say determinant for a while, which is given by x plus a, y plus b, and let's say w and z. This is a 2 by 2 determinant. Now, if I wish to split it in terms of addition of two determinants, what you can always do here is x, w, y, z plus aw and bz. Everybody got this, or shall I re-explain this? All the participants, be quick and respond. Have you all gotten this? So what are we doing here is simply nothing but this part, which was written as a sum of two terms, I splitted it. I hope you're getting it. But other rows or other columns should remain intact. So here, that first row was written as sum of certain terms. So I have splitted it in terms of sum. I hope you're getting it. But apart from first row, whatever number of rows it has, the remaining rows should remain intact. So WZ, WZ, WZ. Are you able to understand whatever I'm suggesting here, whatever I'm doing here? So if I get back to the discussion we are having here, first row could be splitted into sum of three different elements in both the determinants. But apart from this first row, look at the other two rows. They remained intact in both of the determinants. Everybody understood that any determinant can be splitted as a sum or difference of two determinants. Or shall I repeat this? All the participants. Everybody got this? Everybody understood this? Yes or no? Yes or no? All the participants, be quick. Yes or no? Can I move ahead from here? Got this or not? So with this, let's move towards the next property. Let's move towards the next property. Let's try and solve this question asked by JEE Mains in 2024. Based on technically whatever we have studied so far. Shall we? Pay attention, everyone. Here we are. Alpha is not A, beta is not B, and gamma is not C. That's what they have stated in the beginning of this question only. And I am told that this is alpha BC, this is A beta C, this is AB gamma given as 0. This is what we are given. And then they're asking you the value of this expression, the value of this expression. How are we going to do it? Let's have a discussion on that. I hope everyone is paying attention. How do we crack it? Let's talk about that. Everyone with me so far? No confusion. By the way, this is a option-based question and option-based question. I'll be really happy if some of you could participate in this poll and tell me the answer to this question. Will you all? So I'm starting a poll and I'll be really happy if even not in Pylons, you can tell the answer in the comment box also. It will be really happy. It will be really fulfilling. So with this, poll has started. Let's see how many of you genuinely get it without cheating, without using AI or anything like that. Shall we? So this I'm given as 0. So there are two methods. Sir, which two methods? Basic, standard, decent expansion of a determinant or Sarus rule. Do you remember the Sarus rule, don't you? So what does Sarus rule say? I hope again this question also I'm willing to use or expand by using Sarus rule. That shortcut. Sir, what does that shortcut say? That shortcut here says that repeat the first two rows. Do you remember that? Repeat the first two rows. Repeat the first two rows means what? This and this. These two rows, if I write, it will be alpha, B, C, and then A, beta, C. So don't you get confused between alpha, beta, gamma and A, B, C. Remember this. They have deliberately kept it here like this. So if I now expand it with the help of Sarus rule, I think I'll get my answer very quickly. Yes or no? So alpha, beta, gamma. This product I'll get first of all. I hope you remember this method. Plus A, B, C. Yes or no? Plus another A, B, C. Yes or no? Everybody comfortably understanding whatever is being done so far. Minus this A, beta, C. What is this? A, beta, C. Yes or no? Give me a quick confirmation. Alpha BC. This is alpha BC. And there you get AB gamma. There you get it as AB gamma. This is A, B, and gamma. So far, I hope no confusion regarding this. Everybody got this part. I repeat, what did I do? Sarus rule I used. How? I repeated the first two rows. Alpha BC, A beta C I wrote. So alpha beta gamma, then ABC I got, then ABC I got. The product along the principal diagonal elements, and then I took the sum of it. Minus the product along the non-principal diagonal elements. What were they? They were A beta C, then alpha BC. I hope you are seeing the pattern, noticing it, and then A B gamma. And what are we told? Sarus rule says this is the expansion of your determinant. Yes, but this question says this is equal to 0. So this determinant was equal to 0. So this expansion should be equal to 0. Yes or no? Now, if somebody says this expansion is equal to 0, if this minus this is equal to 0, which means what? Which means both of them should be equal. Everybody getting that? Yes or no? Everybody understanding that? Now, by doing something, I'll try to convert this into something like this. Can we do that? I repeat, my only objective is reaching to this conclusion. I want this expression to be developed from this. But how? Let's talk about that. Sir, if you look at it closely, what you need to form here is something as A, B, gamma, and something as alpha minus A in its denominator, beta minus B in its denominator, gamma minus C in the denominator of gamma. How do we do it? One of the methods is you simplify this. You simplify what you are given in the question and you relate it with this. Or the other method is you do some operations on this expression and you reach from here to there. So there are two methods. I repeat, first method, you start simplifying this, which looks decent, obvious, and straightforward. And after starting to simplify this, I may end up getting somewhere close to somewhat like this. And there I'll be able to get my final value. Or the second approach, you use your intuition, you use your some observation and start converting this into this. Everybody understood both of the approaches, yes or no? Or shall I repeat that? I hope so far there is no confusion regarding whatever I've done. Everybody with me so far? I repeat. So with this, let me begin with this approach. first one, and then we'll talk about the second approach as well. So what is the first approach saying to you? Let's start simplifying that result. So if I now start simplifying this, I'll come back to this result which we have developed. Don't worry about this. But let me start simplifying this conclusion which we are given, or this conclusion which value we are asked. So if I start simplifying it, it is A upon alpha minus A, B upon beta minus B, gamma upon gamma minus C. So if I start taking LCM, so in the denominator, I'll have alpha minus A, beta minus B, and gamma minus C. Yes or no? Yes or no? With this A, I hope you are noticing, I will have beta minus B times gamma minus C. If you see the pattern, you will start unfolding it. Now, second thing which you will do here is, hold on for a while, students. Second thing which you'll do here is this B times this and this, which is alpha minus A and gamma minus C. Third thing which you'll do is this gamma times this and this, which is alpha minus A times beta minus B. Everyone getting this, whatever I'm doing here? So if you crack this one, you will see the pattern. This and this you can directly write with those efforts. Now, let me try and crack this first part. How do we do it? Let's just simplify this. So if I start simplifying it, what do I get? I hope you're understanding. This, when simplified, looks like beta gamma into A. So it is A beta gamma. Then beta C, this is A. So this is A beta C, but of course with a negative sign. Yes or no? Everybody with me so far? The next thing, minus B gamma with this A. So this is minus A B gamma. Yes or no? Now the next thing, B and C with this A, that gives you plus A, B, C. Everybody understood the pattern, the cyclicity. Did you all see this? I repeat. First of all, I got beta gamma with this A. The next thing which I got was beta C with this A. Second thing which I got was beta gamma with this A. And the third thing was A, B, C with a plus sign. So I hope somebody must have developed that idea, which we are going to probably get somewhere close to this. Have you started noticing it? We, sir, probably are going to get this. The only thing which will create some problem is if you have started seeing that pattern. Sir, I have gotten an ABC. So if I'm seeing certain pattern here, I think the only thing which is missing from here is that ABC. Why? Because ABC is already there twice. I think one more ABC we need. And with that, we may reach to that conclusion. Getting my point, everyone? Yes or no? Or shall I repeat that? So let me write that whole so that you get this idea. And once I do it from here to there, I'll take you back and tell you that with intuition, how could you have done it? Shall I? Now with this, the next thing which I'll write is, shall I do it on the next page if it is okay? So we'll do it here. I hope no confusion regarding this. I'll remove this part. Okay, I need some space. So I'm removing this part and the denominator, which I'll write later. I hope you are okay with that. So the next thing which I'll get is plus this product. This will be alpha gamma into B. That is B alpha gamma. Next thing will be alpha and C. That is minus B alpha and C. Yes or no? Next thing will be A gamma and B. So that is minus A gamma B. I hope no confusion so far. And then the next term, which I hope is more obvious now, A, C and B, that's again plus A, B, C. So have you all started noticing the pattern now? Have you all started seeing the pattern now? Yes or no, everyone? With this, if I now talk about the third thing, what is the third thing? This result, and your job will be done in the next few steps. What do I mean by that? Let me write the next thing. It gives you gamma alpha beta. So that's alpha beta gamma in a simpler language. Then gamma alpha B, that's minus gamma alpha and B. Yes or no? Correct me if I'm wrong. Next thing will be, I hope we are doing it correctly, alpha minus A and beta minus B. Yes. Next thing will be gamma A B, gamma A beta, but with a negative sign. So it will be gamma A beta with a negative sign. Correct me if I'm wrong. Gamma minus A beta. And the last thing will be again gamma A B. I think there is some mistake, because if this is A upon alpha minus A, this is B upon beta minus B, this should have been C upon gamma minus C. I think there is some typing error. I think so, because to make that pattern resemble with this, it should have been C here. So let me solve this with C. Yes or no? So if I solve this with this C here, I think with this C coming into picture, with this simple correction here, this will be a little simpler and different. What is it going to be with this C? With this C, this will be changed to this here as C. So this will be C alpha beta. I hope you're getting it. This will be C alpha beta minus. This will be C alpha B, which is minus C alpha B, yes or no? The next thing will be C A beta, that is minus C A beta, and the final thing will be again A B C. Everybody got that? Yes or no? Yes or no? So this is our complete expression. This is our complete expression, or rather the numerator. And this whole expression was getting divided by something. That's something I am not discussing right now. But here, if I start simplifying this, let me see if some things are getting cancelled. We'll be really happy with that. So first of all, ABC, 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 you're noticing is going to be 3 times of ABC, which is perfectly fine. With this, few things which you all must have noticed this, that sir, C alpha beta I have gotten. Do we see C alpha beta somewhere else? No. So I'm getting a lot of things, but if I start rearranging it, let me see some similarity here. I don't think there is any similarity, but if I take it back from here, from where, just let me shift it here. This I'm shifting to here. Hold on for a while, students. Here. If I use this result with this result, pay attention everyone. I am seeing alpha, beta, gamma, right? Minus this was given to be 0. Do you remember that idea? Yes or no? So if I see these 6 terms, or rather if ABC is excluded, if I see these 6 terms just like that, I'll replace that whole expression by 0. Getting it everyone? Yes or no? So if I start doing it, pay attention everyone. I have this alpha, beta, gamma, ABC, ABC, alpha, beta, C, alpha, BC, alpha, B, gamma. I think the whole problem we are facing because of this C, this has caused some error. I will see this question changed because there is something wrong with the data. It is either gamma or C, we don't know that. But if I follow the symmetry, it is C. If it is, I'm not following the symmetry, it is going to be gamma. But I think there is something wrong. Shall we do it in the end? I'll get this question checked. And once I get this question checked, I'll get this assurance whether it is gamma or C, and then we'll do it. I'm skipping this question with this belief that there is some typing error, and I'll get this checked. Don't worry. We will do it in the end. Don't worry, completely, thoroughly, and holistically. But right now, let's shift our focus to the next property. I hope it's fine. I assure you, you have my assurance and promise. We will definitely do in the end the question which we have skipped because there is some typo there. And because of that, we'll unnecessarily put our efforts and waste our time. So we'll definitely do it. Don't worry. Shall I get back to the properties we were discussing? So here we are. Sigma of a determinant. What is sigma? Let's talk about this. Based on this, questions are asked. What is this property? It says that, let's say, if you have something like, let's say, r square, r plus 2, let's say, for a while, and here this is 3, this is minus 2. This is a determinant which is given by delta. Getting it, everyone? So here, let's say if I take summation here, if I apply sigma here, so sigma, if you wish to apply on a determinant, let's say where I'm putting r as a variable from 1 to, let's say, 10. So that sigma can be distributed to any row or any column which contains variables r in it. I repeat my point. I hope everybody understood that, or shall I repeat it? All the participants. I repeat. This sigma can be distributed to any row or any column which contains this r in it, because this sigma is applied on this variable r. But one thing you all need to understand and remember and memorize is that here, let's say instead of this r square and r plus 2, if instead of just one row, if it is given in one more row or one more column, can we distribute this sigma to all of those rows or all those columns which contains terms in R? No. it will be false in that case. It will be wrong in that case. I repeat, I hope my statement is very well understood by you all. Let me just check this part here. I hope it is going great. So far, no confusion regarding whatever we are doing. I repeat, if you want to apply sigma on any row or any column which contains that variable r, it is fine. But if that r is there in more than one rows or one columns, you cannot do that. So then how are we going to solve this? In that case, you will have to expand the determinant and then push that sigma. Understanding the difference? But here that r is there in either one row or one column, which is our first row luckily. So I'll apply that sigma on the first row only. Did you get it or shall I repeat it? All the participants, everybody understood that. Now with this, I hope you know in sequence and series, you must have learned these basics that here summation of r square where r is ranging from 1 to 10, summation of r plus 2 where r is ranging from 1 to 10, it's absolutely easy. Summation of r square, do you remember that sum of squares of first 10 natural numbers, n plus 1, 2n plus 1 divided by 6. Do you remember that property? So that gives you n. What is n here? N is 10. So n plus 1, that is 11. 2n plus 1. So 2 into 10 plus 1, that is 21 divided by 6. Getting it, everyone? Then summation over r plus 2. So over addition or subtraction, summation can be distributed. Do you remember that associativeness? So with this, summation of r means what? 1 plus 2 plus 3 until 10. Sum of first 10 natural numbers. You must have memorized it already. If you haven't, it is given by n plus 1 divided by 2. I hope you remember that. Yes or no, everyone? With this, summation over 2. So 2 is added 10 times. Summation over 2 means what? 2 plus 2 plus 2 plus 2, 10 times. So 2 when added 10 times is 2 into 10. I hope it is something really basic, easy and simple. And with this, second row remains intact, which is 3n minus 2. And I hope you know how can simplify this. Those who are asking whether it is for boards or JEE, it is for both. We are starting from scratch from NCERT level theory, and then we are taking you towards JEE Mains with a lot of previous year's questions, of course. So basic scratch, we are starting with the theory comprehensively, thoroughly, every single concept, every single detail we are covering. And then we are consolidating all these learnings with decent and apt amount of examples and questions. But of course, I accept this and I totally accept and digest this that yes, this session alone to cover determinant completely is never sufficient. But to understand the theory and with some apt examples and concepts to get clarity of this concept, this session is always sufficient. But sir, if we want to understand it up to JEE Mains level, what are we supposed to do? Practice questions. What kind of questions? Simply previous year's questions. Which previous year's questions? So far, right now, if you are asking me, previous year's questions from 2022 to 2026. From JEE Mains, start doing this. So after watching this lecture, last 6 years PYQs you are supposed to solve. Once you have done it, you have started feeling amazingly confident on this chapter, then you can shift to advanced. And advanced, I'll say from 2000, solve all the questions so far. And if you have really done it from these two chapters, determinants and matrices, after this video, we'll do same one shot on the chapter matrices as well. Don't worry, I'll do. With these two, if you have watched these sessions thoroughly, trust me, you have my assurance, the whole theory, the entire theory will get covered. And not just that, after that theory, if you have done these questions, with these two chapters, minimum 2 to 3 questions, 12 marks will definitely be attained by you in the mathematics sections of JEE Mains. Not just that, if you have really done these as well, you would get such a decent clarity that advanced also, you will get some really decent score out of these two chapters. You have my assurance. Trust me, mark my words. So this is not just merely for boards. This is for boards come JEE. Rather, I'll say specifically for JEE, but we are starting from scratch, that NCERT level. So shall I get back to this discussion? All I'm saying is simply this. Let's say if you are given a determinant, let's say it is denoted by delta R, which contains either exactly any row or any column in terms of R. So here, let's say second row or third row are absolutely constants, But the first row contains terms in R, somewhat like this, which I have shown you with this example, R square and R plus 2. Now, if somebody asks you to find the summation of this delta R, so if somebody asks you find the summation of delta R, so one of the methods is you expand it. So expansion of a determinant you know now by using the Sarus rule or basic standard descent expansion with respect to any row or any column. But sir, is there any other shorter method as well? Yes, indeed there is. That shorter method says that this summation can be distributed to that row or that column which contains terms in R. Able to understand my language, able to digest what I'm saying? But don't confuse or misconfuse this with this data. I don't know whether there is a word like misconfuse. Confuse is already confusion. Misconfusion will be what? So don't unnecessarily take it as this, that this summation can be distributed to all the rows and all the columns which contains terms in R. No, I did not say so. What did I just say? If either exactly one row or one column, any row or any column, if exactly one row or one column contains terms in R, there you push that summation to that row or that column. But if there are more than one row or more than one column, there are in that determinant which contains terms in R, and if you want to push this summation, no, you cannot. First of all, you get to expand it and then apply summation. Did you all get this, or shall I repeat it? Everybody. Let's say for an example here, I'll just take an example so that you get a complete crystal clear clarity. There is this determinant which is given by R, R square, R plus 2, and let's say 3. And then let's say if somebody tells me, give me a moment, everyone. If somebody tells me to apply summation here, so if I want to find summation of delta, don't say summation R square, summation R plus 2, summation 3. No. You cannot do that. If it is only in one row or one column, then only you do it. But if it is in more than one rows or one columns, you got to expand that determinant first and then apply summation, which means, first of all, expand this determinant. So R into 3, that's 3R. R plus 2 into R square, that is minus R square into R, that is R cube. R square into 2 is minus 2R square because of that negative sign. Now you have gotten that delta, apply summation on it. I hope you got my point. So summation of minus R cube, summation of minus 2R square, and summation of 3R. Of course, 3 minus 2 and minus 1 are constant. They come out of this summation sign, and then I'm left with summation R cube, summation R square, and summation R. Shall I again take you back to the sequence and series chapter? I hope you must have studied it in sequence and series, where you must have learnt summation R cube. Let's say I am taking R from 1 to N. So R from 1 to N gives you what? First N natural numbers cubes sum. That is square of sum of first n natural numbers. Are you getting all what I'm saying? So what does it mean? It says n plus 1 divided by 2 whole square. Do you remember that? Yes or no? Second thing, summation R square. I think you already know that. Sum of squares of first n natural numbers. That is given by what? n plus 1, 2n plus 1 divided by 6. Everybody got that? Plus 3 times summation of R. So 3 times summation of R means summation of R. 1 plus 2 plus 3. That means sum of first n natural numbers. That is given by what? n plus 1 by 2. So this concludes as n plus 1 whole divided by 2. Yes or no? Everybody got that? Everybody understood that? So I repeat. Good, great. Had this R been there in only one row or one column, I could have simply passed that summation to that one row or one column, and my job would have been done in that determinant only. But the problem here is that this R is not just there in either one row or one column, it is there in more than one row or one column. And with this, I got to expand it first, and then I apply this summation. Absolutely easy peasy, your generation and its terminologies. Okay, cool. So with this, shall I move towards the next idea? This is one of those properties on which JEE asks you questions, or this is what you're supposed to apply in almost every single or second or third question based on determinants. Almost everywhere you apply it. Everywhere, almost everywhere. How? Let's talk about everything. Everything. Let's talk about a lot of things. So, what does this property says? What does this property say? This property says something really simple, decent, straightforward. Let's say there is this delta, which contains terms like 2, 3, 5, -1, 7, 4, and let's say 4, 5, and any number you say 1. Okay, so this is delta. This is such a beautiful property that it does a lot of your job or makes a lot of your tasks very easy and simple. How? Let's talk about that. First of all, why, where, and when we apply this property. Whenever we see a determinant and we want to increase the number of zeros there, we want to increase the number of zeros there in it, there we apply it. Although here I'm just randomly applying it just to make you understand this property. But sir, what is this property? I'm telling you. You can always update any row or any column by equimultiples. I've already told that in the beginning. You should watch it from the beginning, Arman. You will see the trick. So I repeat, any row or any column can be updated by summation of equimultiples of some other rows or some other columns, respectively. I know my language was not understood. Let me give an example. So let's say I want to update row 1 with row 1 minus 2 times row 2 plus let's say even 3 times row 3. So what do you mean by this? Even if I perform this operation on this determinant, mark my words, the value of the determinant will not change. So really, yes. That's one of the most beautiful properties of determinants, trust me. How? That I'll explain later, or maybe I will not because it is one shot. We are reserving proofs for the lengthy lecture by lecture discussions, classroom discussions. I'm giving you the properties and the questions. But if I could tell you that this is what you can do, how you can do, let's talk about that. And why we are doing it, let's talk about that. R1, I am updating here. So, sir, you are performing an operation on row 1. So, row 2 and row 3 will remain intact. Yes. So, row 2 and row 3 will remain intact, which means -1, 7, and 4, just like that. 4, 5, and 1, just like that. But what happens to the row 1? Both are easy if very well understood. Krishna. If you are understanding both are easy. And matrices uses determinants. So, they are supplementary. So, what am I doing is row 1 minus double of R2. So, 2 minus of minus 2 into 1. I hope you're getting it. I hope you're getting it. So, I'll write it so that you don't get confused. I'll write it. So, I need more space here. I'll write the second and third row afterwards. So, this is first row 2 minus 2 times row 2. What is row 2? Minus 1 plus 3 times row 3. What is row 3? 4. Did you get that? Did you understand that? With this, great. With this, now I'll apply it with the second element. Row 1 as it is, which is 3 minus 2 times row 2, that is 2 into 7 plus 3 times row 3, that is 3 into 5. Yes or no, everyone? So with this, I hope you got this. 2 plus 2, that's clearly 4 plus 12. 4 plus 12 is how much? Clearly 16. So this element will be 16. Let me write this as well. 7 into 2 is 14. So this is 3 minus 14 plus 15. 15 minus 14 is what? 1. So 3 plus 1 is 4. Let me talk about this element. Shall I do it directly now? 5 into minus 8. 2 into 4. So 5 minus 8. 5 minus 8 is what? Minus 3. Plus 3 into R3. 3 into 1. 3 into 1, that's 3. So 3 minus 3 is clearly 0. Everybody got that? Or shall I repeat it? All the participants. With this, if I write the other two rows, which I definitely can without any hesitation. But one more thing I'll tell you along with this is this, that if you are updating row 1, you have the liberty to update one more row. Krishna, if you're taking coefficient of R1 other than 1, then you got to divide it by that number, as we have just discussed in the previous properties. Let's say mistakenly, if you put a 7 here, then you'll put a 1 by 7 here to balance it out. Do you remember that? I think we had a discussion on this property. So had you been watching it from the beginning, you would not have asked that doubt. We have already covered it. No worries. Now, I'll say one more thing here. It is a 3 by 3 determinant. It is a 3 by 3 determinant. So if it is a 3 by 3 determinant, the maximum number of operations which you can perform at a time will be 3 minus 1, 2. So if I have applied one operation here, I am still having that liberty to apply one more operation. Getting my point? So let's say, just to make you understand, I'm applying one more operation simultaneously, which I'm given by R2, I'm updating by R2 minus R3. Now, very interesting doubt asked by Krishna. He was saying that, sir, if you multiply this row 2 by, let's say, 3 here, then of course, remember, R2 has to stay R2. If you're updating R1, R1 has to stay R1. But let's say if I'm multiplying this R2 by 3, so to balance it out, I got to divide it by 3 here. I hope you're getting it very clearly. You don't update the row by multiplying it by some other value. I hope no confusion so far. Everybody with me, yes or no? Yes or no? So, R2 minus R3, I think that's very easy now. R2 minus R3, so minus 1 minus 4, that's minus 5. 7 minus 5, that's 2. And 4 minus 1, that's 3. But don't say that, sir, you can take one more row now. You can apply operation on one more row. No, this is a 3 by 3. So on a 3 by 3, the maximum number of operations which you can apply is 3 minus 1, that's 2. So third row has to remain intact. So 4, 5, 1. One more constraint or condition I wish to apply or tell here. What is that? Sir, at a time, either apply rows operations only or column. Don't do both simultaneously. So right now I applied rows, columns in this step. Maybe you want to apply more, let's say column-wise operations. You can, but not in this one. So at a time, apply only rows operations or column operations, but not both. Getting my point, everyone? Yes or no? Shall I move ahead from here? Everybody understood this whole idea? Yes or no? Everyone. With this, I am going to explain you this property, which is simply nothing. But let's say, if this is a determinant delta A1, B1, C1, A2, B2, C2, A3, B3, C3, then you have the liberty that you can update R1 by R1 plus M times R2 plus N times R3 as well. But let's restrict our discussion to this only so that it stays understandable. R1 plus MR2, which means A1 plus MA2, B1 plus MB2, and the third one, C1 plus MC2. So my first row now will look like this. A1 plus MA2, B1 plus MB2, C1 plus MC2, and the other two rows will remain intact. A2, B2, C2, A3, B3, C3. Sir, why are we doing this? So that we can maximize the number of zeros in our determinant. Sir, why are we maximizing the number of zeros? So that the more number of zeros we have, the easier it will be for us to find out the value of the determinant, as we have discussed, I think, in the first slide of our discussion. The third thing, if I can do this, I performed an operation on a row. How many operations at a time can I perform? Let's say either row wise or column wise. So I have already discussed or told, if it is a 3 by 3, there the maximum number of operations, either row by row or column, you can perform would be 3 minus 1, that's 2. So one operation on a row I performed. Simultaneously, one more operation I could have performed. After this step, more I could have performed, but at a time, n minus 1. 3 minus 1, that's 2. Will you all remember this fact? I hope there is no confusion. But sir, how are we going to apply these learnings? Why are we doing this? I'm skipping this proof here This is the whole proof, which you can keep it for yourself. Sir, how are we going to see this proof after the class, after the session gets over? You have this feature available that this entire PDF of this entire one shot of the whole chapter determinants will be uploaded on our WhatsApp channel. Sir, where is your WhatsApp channel? WhatsApp channel is on WhatsApp, but the link to our WhatsApp channel is given in the description. So if you check the description, you will see the link to our WhatsApp channel. And after the session, once the session gets over, the entire PDF of this entire one shot of determinants will get uploaded on our channel. You can check it there afterwards. Shall we get back to our discussion? So this whole proof, which I'm skipping in this one shot, is there written for you. You can check it out by yourself. So few things which we have learned so far regarding operations on rows and columns. Let's quickly go through them. Pay attention, everyone. Here, if I mistakenly do this, somebody asked this, so let's revise it. If I mistakenly do this, R1 updated by MR1 plus R2. So the row which I'm updating, that I'm updating with MR1. So that row itself got multiplied by a constant. You can do that. Nothing wrong in that. So it will be MA1 plus A2, MA1 plus B2, MC1 plus C2. But the whole problem is it will not remain that same delta again. It will now be that M times of delta. What does it mean? If you are updating a row where mistakenly you are multiplying that row, same row, by some constant, then that determinant has to be divided by that constant to keep it balanced. Everybody remember that fact? Yes or no? Yes or no? All the participants who are sincerely watching and understanding. Now, I hope now you're clearly understanding that if this is a 3 by 3, so I can perform either row by row or column by column operations at a time. Not row and column both together or simultaneously. Absolutely not. One more thing, if it is a 3 by 3, maximum 2 operations, either row by row or column by column, can be operated or performed. Whosoever is appreciating me so much, thank you so much. I've never seen such kind of appreciation. Thank you so much. So R1 is going to be R1 plus MR2. Let's say one operation. Second operation, I think there is a mistake, no mistake. Second operation is R1 plus NR3. So these are two different operations. Trust me, you can skip these two different operations and club these two different operations in one operation, which is given by this. I repeat, R1 with R1 plus MR2 and R1 with R1 plus NR3 can be clubbed into one single operation as R1 getting updated by R1 plus MR2 plus NR3. I hope number of operations got reduced, your calculation became easier, and you are doing lesser efforts now. You are putting lesser efforts. So I hope you got this. This is delta, which is A1, B1, C1, A2, B2, C2, A3, B3, C3. That is still that delta. It is still unchanged. This is still intact. This still remains same. A1, MA2 plus NA3. B1, MB2 plus NB3. C1, MC2, NC3. And why are we doing this? Just to increase the number of zeros. And if we increase the number of zeros, the expansion of the determinant will be easier. That's the whole idea of doing all of this. Everyone comfortably got this, the whole explanation. Shall I move ahead from here, all the participants? I think we have discussed it. So this property, maximum n-1 rows or columns can be changed in one go for an n-order determinant. No confusion regarding this? Let's try this question. It's a proof-based question. Rather, I'll say that let's apply the properties of the determinants and it's not proof, it's solve. So we need to find the value of x. I hope you're realizing, even if you apply Sarah's rule here, how complicated it will be. Are you noticing the complexity here? So how do we avoid that complexity? How can we get rid of that complexity? A really simple idea it is that simply apply those operations which you have just learned, so that the value of the determinant remains intact, unchanged. Sir, how do we apply that? Let's talk about that, all of that. I will do this. What? Sir, I'm noticing something. X, 2x, 2x, 3x, 3x, 3x. So if I do few things, I may get rid of this 2x, 2x, 2x and 3x, 3x, 3x. How? Let's talk about that. So column wise, I'm going to operate. How? Let's learn that. Can somebody write in the comments what column wise operations will be really easier and simpler for us to apply here to make this calculation very simple and easy and doable. Can somebody tell me in the comments? So here, first operation which I'm thinking of doing is column 2 I'll update by column 2 minus 2 times column 1. Can somebody tell me why am I doing this? Has somebody noticed why am I doing it? I hope somebody must have understood 2 times. 2 times of column 1 from column 2 will help me in getting rid of something really simple. Tell me in the comments, students. I hope you're realizing since it is a 3 by 3 determinant, maximum number of operations I can perform is 2. So why not avail one more? So here, one more I can do. Sir, can you not update column 3 by? Column 3 by what? By column 3 minus 3 times of column 1. Sir, why did you do it? Somebody must have noticed it and write it in the chat box. Why? Because 3 times of it, if subtracted from this, will lead you towards something really interesting. Are you noticing that? Yes or no? Yes or no? Yes or no? So with this, I think I have gotten to something really important conclusion that this determinant, which looks like amazingly complex to be expanded, I think I'll do it in a very simpler manner now. Let's look at that. Let's look at that. First of all, sir, have you done anything on column 1? Absolutely not. So that remains intact. That remains unchanged. So column 1 is not affected at all. So column 1 stays like x minus 2, x minus 4 and x minus 8. Yes or no? Now the next thing, pay attention everyone. Column 2 minus 2 times column 1. So this minus double of this. Can you imagine this? Can you visualize this? I'll be doing it in the air. So 2x minus 3 minus 2x minus 4, but negative of it. So 2x minus 2x getting cancelled. If you're not able to imagine this, I'll write it. So this is what? 2x minus 3 column 2 minus 2 times column 1. So this is 2 times x minus 2. Are you getting it now? Is it understandable? Similarly, here 2x minus 9 it is. From this, I am subtracting double of this. So 2 times x minus 4. Now, I hope those who could not notice must have started understanding why are we doing it. Yes or no? The next thing. From this, I'll subtract double of this, column 2 minus 2 times column 1. So this is 2x minus 27 minus 2 times x minus 8. Ideally, a JEE sprint doesn't do like this. But just to avoid your confusion, since you're watching it for the first time, let's say the chapter determinants, we are doing it in such a simple manner. Now, one more thing you're supposed to do. So what? You are supposed to subtract 3 times of column 1 from column 3. So what is column 3? Column 3 is 3x minus 4 minus 3 times of column 1, which means 3 times of x minus 2. Then 3x minus 16, 3x minus 16 minus 3 times of column 1, which is 3 times of x minus 4. Then 3x minus 64, 3x minus 64 minus x minus 8, triple of it. Yes or no? So this is what we'll be doing. Sir, have you not made it unnecessarily complicated? Trust me not. It may look a little complicated. I have tried doing it in as simpler manner as I can so that it stays understandable. Although you really don't have to do it if you are really preparing for JEE. What you can do here is simply simplify this algebraic expression and get to the final part. Sir, what is the final part? Pay attention everyone. 2x minus 2x, that's cancelled. Minus 3 plus 4. This is plus 4 minus 3, that's 1. So this whole gets replaced by 1. Same, 2x minus 2x, you'll see the beauty now. 2x minus 2x, that's 0. 9 plus 8. Minus 9 plus 8. How much is that? I think that's minus 1. Everybody getting that? Same here. 2x minus 2x, nullified. Minus 27 and that's 16. Yes or no? So minus 27 plus 16 it is. I hope you're understanding. So 16 plus 11 is 27. Yes or no? 16 plus 11 is 27. So minus 27 plus 16 is minus 11. Did you get that? Or I repeat it? I hope no confusion so far. So this is plus 16 minus 27. 16 and 27. I hope you're understanding the difference is going to be 11. So I'll write it as minus 11 because it is minus 27. So this is minus 11. Now, are you noticing it? How easy it has become now? With this, 3x cancelled. Minus 4 plus 6. So 6 minus 4, that's plus 2. So this becomes plus 2. Noticing it? Same. 3x cancelled. Minus 16 plus 12, that's minus 4. So here it should be minus 4. Then just give me every moment, everyone. There. 3x got cancelled. 8 into 3 is 24. 64 plus 24, I think is 40. Yes or no? And it's minus 40. Everybody listening, watching and understanding with sincerity. So I repeat, minus 64 plus 24, that's 40. So this will be minus 40. So I'll write it as minus 40 if you are comfortable with this. So far, whatever I've done, is that understood by everyone? There is no confusion, I believe so. It is very well understood by everyone. Yes or no? Yes or no? Give me a quick update. Give me a quick update. So far, I hope it is very well understood by everyone. Now, if you want to expand, you can. But if you want to keep it a little simpler or more simplified, you can make it. How? Let's talk about that. Let's talk about that. I can add these two so that I get a 0 here. And then I think apart from that, I can do one more thing, but it will unnecessarily put some value. So I think I'll stop here and then I'll expand it now. I will expand it now. So how will I expand it? Let's talk about that. I think the job is almost done. You just need to expand it. So with respect to whichever row or column you wish to, you can. You wish to use Sarah's rule, you can. Whichever method you wish to use, you can. So let's start talking about that. Everybody paying attention. I'll be using a simple expansion here. Decent, standard, straightforward expansion I'll be doing. So with respect to whichever row or column you want, you can use Sarah's rule. Whichever method you wish to use, you can. No obligation or objection here. You can, as per your choice. So let's say I am choosing standard basic method of expansion with respect to row 1. Or sir, if you want, you can have done it with respect to column 1 as well. Now, column 1 also you could have taken, row 1 you could have taken, whichever way you want, you can. So let's say instead of row 1, if I'm choosing column 1, that way stays simpler. So with column 1, I hope you remember plus, minus, plus, minus, plus, minus, plus, minus, plus. So plus, minus, plus. Do you remember that sign scheme? So that sign scheme says x minus 2 with a positive sign. It's minor, which I'll write later. Negative of x minus 4, then it's minor. Then positive of x plus 8. And it's minor. That minor I'll start writing now. So with this x minus 2, I hope you remember this into this minus this into this. Do you remember that? So minus 1 minus 40, that's plus 40. And minus 11 minus 4, that's plus 44. But with the negative sign, it will be minus 44. Getting it, everyone? Standard basic expansion of a determinant. Now, with this x minus 4, remove this row and this column. So I'll be left with 1 and minus 40. That is what? Minus 40, yes or no? And minus 11 and 2, minus 22. But minus of minus 22 is plus 22. Everybody comfortably getting it? Then for x plus 8, sorry, it's x minus 8. Why did I write x plus 8? I think I mistakenly done it. And nobody is highlighting it. Where are you all? Are you all watching it sincerely? So there I'm having this x minus 8. For this x minus 8, the expansion will be 1 into minus 4, which is going to be what? Minus 4. And this minus 1 into 2, which is minus 2. But minus of minus 2 is plus 2. And this whole thing is given as 0. So I'll put it equal to 0. So far, is there any confusion regarding anything whichever I've done so far? Whatever I've done so far? I hope it is absolutely understandable. Yes or no? Yes or no, everyone? Shall I move ahead from here? All the participants? Everybody watching it with utmost sincerity and focus. Okay, give me a second, everyone. Here we are. So if I start simplifying it now, my job will be done with this next step, probably. 40 minus 44, that's minus 4. Minus 4 into x minus 2, that's minus 4x plus 8. Everyone getting that? This minus 40 plus 22, I think that's 18, but with a minus sign. So minus 18 minus plus 18. So this will be plus 18x plus 18 into minus 4, that is minus 72. Yes or no? So that is minus 72. With this is minus 2. Minus 2 into x minus 8, that is minus 2x plus 16 is equal to 0. So I think we are very close to the final answer now. Yes or no? So with this, 4x and 2x, that's 6x. 18 minus 6, that is clearly 12x. Then what am I now left with? Pay attention. 8 plus 16, that I think is 24. And this is what? 72. And 72 is triple of 24. So I'm left with double of 24. I'm forgetting my language. So it is minus 48, which shifts to the other side, becomes plus 48. And I hope I need not tell you, this is 4 times. So x we have received as 4, which is our final answer. So this was needed to be solved, and it gives you x as 4. Yes or no? Everybody got this. Everybody understood this. Thank you so much for your kind words. Thank you so much for your appreciation. I hope no confusion regarding this. Everybody understood this whole idea. First of all, 3 things I wanted you all to understand. If something like this as a given in terms of determinant, you don't straight away start expanding it. Then sir, what are we supposed to do? Apply those properties of determinants which we have learned so far. Why? So that it looks simpler, it becomes easier, so that expansion becomes simpler. If you start expanding it, it can be, but calculation wise, it will be very complex and you're prone to make mistakes in that case. You will definitely make mistakes. You will commit mistakes because it will be amazingly, terribly, complex. Then the next thing, once you have applied those properties, standard expansion, standard solution was there. So it was a simple question if you know how to apply the properties of determinants. Everybody got that? Everybody understood that? Shall I move ahead from here, all the participants? Shall we move towards the next idea? This is a question asked by JEE Mains. Let's try and solve this. Shall I take a break? So let me take a 15 minutes break and then we'll resume. Okay, so this is a question which I'm leaving for you all and I'm starting a poll and I'll be seeing, I think this is a previous question. Let's stop this. But we are starting a poll for this question now, single choice. So let's see how many of you get it right. And I'll be really happy if some of you could do it correctly. So we'll be back in 15 minutes. It is 11:10. So again, there is a break of 15 minutes. And 11:10 it is, right? So we'll resume at 11:25. So you also take a break, hydrate yourself, stretch yourself, walk a little, but stay around, come back after 15 minutes. Okay, we'll meet in 15 minutes. So here we are. Come back, everyone. Come back, come back, come back. I hope you all can see me screaming, shouting, loudly speaking that come back, everyone. So if anyone is around, went back, if my voice you can hear, come back, come back. So I hope we can get started, everyone. Let me block few people so that we can stay focused and do unnecessary, irrelevant discussion takes place and we can talk the relevant stuff here, right? So let me just remove few people so that nothing irrelevant happens and we can stick to the agenda. All right, great. So we are resuming our discussion. I hope so far whatever we have done is very well understood by everyone. And let us now discuss this part here. Everybody, what are we told in this question? This is a determinant which is given equal to this. And this equation has the solutions lambda and lambda by 3. Then, apologies, this expression is equal to this. On the LHS, this is an expression, which is an expression in lambda and x. But on the RHS, this is an expression in x only. Getting it, everyone? And I'm told lambda and lambda by 3 are the roots of this equation. Okay, okay. Are you all not realizing or thinking or understanding that, sir, instead of all of this, if you know one basic concept, that this is technically nothing but an identity. What is an identity? Identity means it is true for all the values of x. That's good. But why are you saying that, sir, it is an identity? Because there is x on the LHS, x on the RHS, so it should be satisfied by all x. The moment I say this, I'm giving you a hint to solve this question. How many of you have genuinely and already done this? How many? Can someone answer this? That's good, good, good. Solve it. That's good. So with this, I am suggesting you that if I put x is equal to 0, if I put x is equal to 0, I'll have 0 plus 1, 0, 0 in the first column. So it will be 1, 0, 0. It will be 0, lambda 0. So it will be 0, lambda 0. I'm really sorry. Lambda and lambda by 3 other roots. Yes, we are going right. And this will be 0, 0, lambda square. This will be 0, 0, lambda square. Yes or no? Everybody got this, or shall I re-explain this? Since, yes, absolutely, Naman. So if it was an identity, it has to be satisfied by all the values of x. If I have that liberty to keep any value, will I not say that, sir, replace x by 0 on both the sides? So this 0 into this will be completely nullified. 9 by 8 into 81. So this will be 9 by 8 into 81. Getting it, everyone? So far, is there any confusion? Yes or no? Let me just remove some unnecessary elements who are simply ruining our healthy discussion with their irrelevant stuff. So far there is no confusion, I believe so. Now, with this, I think I just need to simplify this. Shall we use the Saras rule? So if I could use this, or even if you want to simplify this by using a basic idea or a basic notion, what will you do or say here? Sir, I'll do just one thing, that I'll use this expansion with respect to either first row or first column, which means this 0 and this 0 will not matter at all. I hope you remember. And with this one, this lambda into lambda square minus 0 into 0. Yes or no? So I hope you are noticing this is clearly a diagonal matrix, because all the non-diagonal elements are 0. Do you remember the diagonal matrix discussion? So with this diagonal matrix discussion, I am simply telling you one simple fact, that here, all of these and all of these non-principal diagonal elements are 0. Then the value of the determinant is always product of these principal diagonal elements. Did you listen to what I've just said? It is simply evident, because if you expand it with respect to either first row or first column, this into this minus this into this, I hope you're able to imagine or visualize this. So it will be 1 into lambda square. So what do I get? Ultimately I get what? I get lambda cube, because lambda into lambda square is lambda cube, as 9 into 81 by 8. Yes or no? Any confusion so far? Absolutely. And this is, I think, 9 into 81 by 8. And I hope there is no confusion regarding this. Lambda cube stays like that, but 9 into 81 means what? This is 3 square into 3 cube. Sorry, 3 square into 3 to the power 4. Yes or no? Whole divided by 2 cube. I hope 81 is 9 square, which is 3 to the power 4. This is 3 square. So in the numerator, it is 3 to the power 6. Any confusion so far on whatever is being done? So this is 3 to the power 6. So if I take cube root, lambda will be 3 to the power 6 by 3, which is 3 square. And this will be 2 to the power 3 to the power 1 by 3, which is 2. So lambda will be 9 by 2. Everybody got this? Everybody understood this? That how did I crack lambda here? It is going to be 9 by 2. Any confusion so far regarding lambda? So if you have understood lambda, I think half of our question, or rather 80% of our question is done. Sir, why? Because now I'm simply left to work out the next part of this question, which is mainly related to a basic quadratic equation. So lambda we have cracked to be 9 by 2. So if lambda is turning out to be as 9 by 2, what will be lambda by 3? 9 by 2 by 3, which is 3 by 2, which is 3 by 2. Yes or no, everyone? Yes or no? With this, these are the roots of an equation. Sir, equation means what? Quadratic. So if it is a quadratic which has two roots, we know how to write the equation. Either you check it from here, whichever option is satisfying will be the answer, or the other method could be create the quadratic. Sir, if two roots are given, do you remember that? If let's say one of the roots is alpha, other root is beta, quadratic is given by x square minus sum of the roots time x plus product of the roots. This is what you must have studied in 11th theory of equations. With this, you finally come up as the answer to this question as x square minus sum of the roots. 3 by 2, 9 by 2. I think that is 9 plus 3, 12 by 2. Yes or no? So 12 by 2 turns out as what? I think plus it is. So 9 plus 3 is yes, 12 by 2. That is 6x. Then alpha beta. 9 into 3 is 27 by 4. So this will be 27 by 4. And I think now you are clearly seeing 4x square. 6 into 4 minus 24 plus 27. So option D. Everyone noticed it. Everyone saw it coming. Everyone realized it. Everyone understood this, yes or no? And I'm sure somebody must have given the correct answer. Let's see. Unfortunately, no one. It's perfectly fine. But some people are participating. Where are they? I don't know. But you can tell me the answer in the chat box as well. It is perfectly fine. If you're not participating in this poll, you can answer your, put your options in the chat box as well. We'll really appreciate that. So shall I move ahead from here, all the participants? No confusion so far? Yes or no, everybody? Yes or no, everyone? Shall we move ahead from here? With this, I'll move ahead with the next question. How do we solve this? Shall we try this? Never. Tanay, one-shots are never enough for even I'll say JEE Mains. So JEE Advanced is absolutely a totally different story. But let's say, okay, Sovi, I hope you understood it. It should be option D in that case. Now, I'll simply say you one thing. Pay attention, everyone. Why are we going ahead with this one-shot series? Let me give you clarity on this. Why are we going? This one-shot series is the NCERT basic. That means theory we are covering completely. We are taking apt examples, and the questions we are taking is mainly through JEE Mains. So this is what we'll be covering. And we are ensuring that with every single one shot, we cover the chapters from 12th. So this is what our intent is in this series. But we don't stop here. We say, if you watch this one shot, what will you get? JEE Mains Advanced? No, I'm not saying that. I'm not claiming that. I am saying a chapter will be covered comprehensively or thoroughly with decent theory, comprehensively and thoroughly, and with apt or appropriate number of questions. But after this, what you are supposed to do as student is start solving questions. What questions are? PYQs. As of now, begin with mains PYQs. And afterwards, go to the advanced PYQs. Sir, in means there are a lot of questions. Shall we do all questions? Absolutely not. The most relevant PYQs will be from 2020 to 2026. But in advance, you don't have much questions. Once you have done PYQs from determinants of mains for the last 6 years, you can do the last 26 years PYQs of JEE Advanced. Trust me, if you are really doing all of this, you will definitely get something. So avoid going for any book or something like that. You can always focus on, hold on for a while, students. You can always focus on PYQs. Theory we are getting covered with apt examples, and we can solve a lot of questions along with this. Everyone with me? I hope there is no confusion. Let me get back to this question now. How do we solve this? I am told xi is a number ai, bi, ci, where ai, bi, ci are the digits. What does it mean? It means, give me a moment, everyone. It means, let's say there is a number which is written as 562. So this is a number, let's say for a while, x1. So this is ai, this is bi, this is ci. They are the digits. Of course, why would we not? So I hope you know this basic idea. Let's say there is a number 562. So this is what you must have studied in 4th standard probably in maths. 562 is technically 5 into 100 plus 6 into 10 plus 2. We use decimal system. So 10 to the power 0 into 2. I'm really sorry, this is plus. Plus 10 to the power 1 into 6 plus 10 to the power 2 into 5 and so on to write these numbers. You know this basic idea? What if this basic idea I use here in this question? How? Let's talk about that. So xi, ai, bi, ci, that means there are 3 numbers. Which 3 numbers are? First number x1, which is a1, b1, c1. Second number is x2, which is a2, b2, c2. Third number is x3, which is a3, b3, c3. That's what they have told you. I is 1, 2, 3. 3-digit positive integers. Yes or no? Now with this, pay attention everyone. Positive integers such that each xi is a multiple of 19, which means a1, b1, c1, a2, b2, c2, a3, b3, c3. These are the 3 numbers and they are multiple of 19. Multiple of 19 means this x1 can be written as 19 times, let's say n1. x2 can be written as 19 times n2 and x3 can be written as 19 times n3. Multiples of 19. Getting it or not, everyone? With this, what am I told next? Sir, you need to prove that this determinant is divisible by 19. Okay. How? Let's talk about that. If you know the basic properties of determinants, which you have learned to simplify the expansion of a determinant, and if you apply those properties here in this question, your question will be absolutely, totally, simply done. Let's talk about that how. So, I hope this x1, which in terms of digits looks like a1, b1, c1, will you not say it is actually 100 a1 plus 10 b1 plus c1? Getting my point? This x2, which looks like a2, b2, c2, is originally, in terms of digit, it looks like this. I hope you're getting it. But it is originally what? 100 times a2 plus 10 times b2 plus c2. Are you getting my point, everyone? This x3, which is a3, b3, c3, is technically 100 times a3 plus 10 times b3 plus c3. Everybody got this whole idea? Yes or no? Yes or no? So I think if you have gotten this whole idea, your question is totally done. How? Let's have a detailed discussion on that. If I simply apply some operations on this determinant to make one of the rows or columns or look like this. Sir, how are you going to make that happen? Pay attention. I want 100 a1 plus 10 b2 plus 10 b1 plus c1. So let me do this. In row 3, I am making an amendment. What operation, what change? In row 3, I am having, of course, row 3 as it is, plus this row 3 can I write later, plus 100 times row 1 plus 10 times row 2 plus row 3. Brilliant. What did you just say, sir? I am saying that I am performing an operation where row 3 is getting updated by 100 times of row 1 plus 10 times of row 2 plus row 3. Have you noticed something? I'll show it to you. The value of the determinant wouldn't change, first of all. The value of the determinant wouldn't change at all. But what advantage will we get? We are going to get in the by having this operation. Row 1 and row 2 will remain intact because I'm performing the operation on row 3. So row 1 will be A1, A2, A3. Row 2 will be B1, B2, B3. But what happens to row 3? Let's talk about that. Pay attention, everyone. 100 times row 1, that is 100 A1, plus 10 times row 2, that is 10 B1, plus row 3. So imagine in row 3, I have written 100 A1 plus 10 B1 plus C1. What is that? So that is X1. And X1 is a multiple of 19. So can I write it as 19 N1? Remember that, everyone? Yes or no? With this, now the next part, with the second column, of course, the third row I'm talking about. So 100 times row 1 plus 10 times row 2 plus row 3. 100 times row 1 plus 10 times row 2 plus row 3 is going to be this, which is x2. And x2 is a multiple of 19. So can I not take it as 19 and 2? Everybody got that, or shall I repeat it? Yes or no? All the participants who are watching it sincerely, got it or not? Now the next thing, the third thing. Here, x3. 100 times A3, 10 times B3 plus C3. 100 times A3 plus 10 times B3 plus C3. Which gives you what? Which gives you x3. And what is x3? 19 and 3. Because x3 is also a multiple of 19. So this particular value, can I not substitute by 19 and 3? Yes or no? Everybody got that? Yes, we do. So with this, I hope you do remember that with any row or from any column, I can take a certain element common in a determinant. Remember that? So 19 looks common here. So if you take 19 common from the third row, it looks like what? Shall I do it here only if you're fine? Or let me do it here. A1, B1, N1, A2, B2, N2, and A3, B3, N3. Yes or no? And I am taking 19 common out of it. Now pay attention, everyone. I am giving you a very simple idea, a very simple observation that when you simplify this, when you expand this determinant, they all are integers, A1, A2, A3, B1, B2, B3, even N1 into N3 are also positive integers. So when you expand a 3 by 3 determinant with all positive integral terms, it is going to be an integer. It is indeed going to be an integer, yes or no? Everyone getting that? Everyone, yes or no? So with this, if this whole determinant is going to give me an integer, because I hope you know, with whichever row or column you expand, or even with Usaris rule, this when you expand all these integers terms, when multiplied and added and subtracted, will give me an integer only, that too. And that integer into 19 will be a multiple of 19. So this ultimately is a multiple of 19, which I can write as 19k. And I think that's exactly what we were supposed to prove. Everybody understood that? Everybody got that, or shall I re-explain that part? Yes or no? Give me a quick update, students. Now with this, we'll, we'll move towards the next question. Here we are with asked by JEE Mains. We'll think about it, Tanay. We'll definitely think about it. You rewatch it. If you're still not able to understand it, I'll do it. Don't worry. If you watch it from the beginning, you will understand it. I have taken care of every single step. Now this question, it says A here is a 3 by 3 matrix. Okay. And it says determinant of A to be 4. It is giving you the value of determinant of A, which is said to be 4. Ri denote the ith row of A. I think it is absolutely understandable. And if there is another matrix B, there is another matrix B. So I hope so far matrix is not very confusing to you all, although we haven't studied it as a chapter, but I hope you're making some sense out of it. Yes or no? That matrix you have obtained by performing this operation. I think if some of you have studied the operations properly, green tea, if you are studying these operations properly, I think your job is done. R2 updated by 2 times R2 plus 5 R3. Sir, in R2, if you update it with equi-multiples of some other rows, it wouldn't change the value of the determinant. But what you have done here is mistakenly, R2 is updated by twice of R2. Had it been just R2, I would have kept the matrix to be same. But are you all not noticing that, sir, there is a simple change or a major problem you have created by multiplying this by 2? Yes or no? And not just that, you have not done it on A, you have done it on 2A. You have done it on 2A. With this, what is going to be the value of determinant B? Although I could show it to you with a 3 by 3 matrix as well. But if you are a sincere JEE aspirants, you really don't have to do it like what I'm going to do. But to make it understandable, to keep it simpler, I'll do it. Because you haven't studied matrices so far. You don't know the properties of matrices. That's why I'm doing it. Although you really don't have to do it like the way I'm doing. Absolutely not. So let's say there is a 3 by 3 matrix. So let me say that there is a matrix A, which is a 3 by 3. So I'll take it as A1, B1, C1, A2, B2, C2, and A3, B3, C3. You don't have to do it like this if you know the properties of matrices. If you have studied matrices, you won't have to do it. But let's say you have not studied it, so that to make it understandable, I'm doing it step by step. So this is a matrix A. This is a matrix A, right? Now, this is matrix A and I'm taking 2A. So I hope with matrices, if you multiply it by scalar, that scalar is multiplied to all of its rows and columns, to all of its elements. So if somebody ever asks you, how will 2A look like? 2A will be nothing, but 2 is multiplied to all of its elements. So it will look like 2A1, 2 B1, 2C1, then you have 2A2, 2B2, and 2C2. The third thing will be 2A3, 2B3, and 2C3. Did you all get this? Any confusion so far? Just give me a second. I need to have some water and then we'll resume. Give me a moment, everyone. Even if the coefficient is 2, we can deal with this. And that's exactly what I'm wanting to tell here in this question. How? So this is going to be 2A. Everyone comfortably got this? Now, from here, I will say that what operation have they performed? Shall we talk about that? Yes, let's talk about those operations now. So if I now talk about those operations, what happens here is going to be this part. I am performing this operation on 2A. So let me get rid of this A here. Let me get rid of this A and I'm performing an operation twice of R2 plus 5 R3. So on this 2A, if I perform this operation, which operations are twice of R2 plus 5 R3. So now, let's say this is what 2A, right? And on this 2A, I'm performing an operation. Which operation, sir? Let me just remove this part. Twice of R2. So double of second row. double of second row. But before I do this, what is it? Sir, this is 2a. This is 2a, yes or no? And let me treat it as a determinant now. Can I? Of course you can. We have not studied matrices. That's why I'm restricting my hands from using that property. Once we do it, you will start understanding it. So now, with the determinants, when you take something common, it is taken common out from either any row or any column. So here, when I take this 2 common from the first row, second row, and third row, from matrices, had it been taken common, it would have been just 1, 2. But if I'm taking it common from a determinant, it is taken common not from the whole determinant, it is taken common from first row, then another 2 is taken from second row, then another 2 is taken from the third row. So are you all not thinking that this 2, 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 this 2. So if you have taken it common from the first column, it was 2. From second column, another 2 came out. And from third column, another 2 came out. So technically 2 cube came out. Did you all understand this? Yes or no? Everybody, yes or no? But sir, the story didn't end here. The whole mistake which you committed was you performed an operation as well, which was not a mistake, but still, if I performed an operation where I'm making a change here, that I'm updating R2 by twice of R2. And if twice of R2 is what I'm doing, I think if that operation is being done on this, which is of course not this anymore, I got to divide it by 2. Do you remember that? If any determinant, any row is updated by that same row multiplied by some value. So to balance it out, whatever operation I have done inside this, I don't mind that. I don't care. It will still remain that matrix only. It will still remain same determinant only, which was our determinant A originally. This A1, B1, C1, A2, B2, C2, A3, B3, C3. That still remains determinant A only. But I made a mistake that I multiplied R2 by 2. So to balance it out, I have to divide it by 2. Do you remember that? Yes or no, all the participants? And with this, I think now you are very close to concluding the answer. You all are very close to concluding the answer, yes or no? I hope some of you must have noticed that, sir, this is nothing but what? The matrix B, which you have attained. So determinant of B you're asking. Determinant of B you're asking. And if you're asking determinant of B, I think we have this originally was matrix B. So determinant of B is going to be this, yes or no? So I repeat, this was your matrix A. I hope you remember that. And this is your matrix B. So far, I believe there is no confusion. And if you're asking me the determinant of B here, so this is going to be the determinant of B, the whole of this, where this is the matrix. I am actually struggling here, because this question I would do with the basic property of matrices, but that I haven't taught you right now, and my hands are restricted and confined. Let me tell you that property. The property says that there is a matrix A and its determinant is given by, let's say, delta. So if that matrix A is multiplied by a scalar, then it is given by k to the power n times determinant of A, which means k to the power n times delta. But since we have not studied this chapter matrix as of now, that's why we are actually struggling a little bit with this property. But I am sure most of you must have understood that property. I'll explain that property and then I'll come back to this question. Let me explain that property first of all. Then we'll come back to this question. All I'm saying here is a simple fact. Pay attention, everyone, that let's say there is a matrix A. Right, it has 4 elements. I'm taking a 2 by 2 just to make you understand this. It has 4 elements A, B, C, D. And if I multiply it by 3, so what will be 3A? So when you multiply a matrix by a scalar, so that scalar is pushed to all of its elements, which means it will be 3A. Don't worry, we'll study it in the one-shots of matrices as well. But right now, we need it in this question. That's why we are understanding this property. But this property will cover as an independent property when we study matrices. Don't worry. So with this, now, if I'm asking you to tell me determinant of 3A, so what will you say? Sir, determinant of 3A will be determinant of this, which is 3A, 3B, 3C, and 3D. Everyone getting this? Yes or no? And with this, I hope everybody must have now realized that, sir, If you take 3 common from first row and second row, then it is a determinant. You didn't take this 3 whole common. Actually, you take it from row or columns, row wise or column wise. So if I'm taking 3 common from the first row and second row, I'll have 3 from the first row as 3. Second row also gives you another 3. So this gives you 3 square. And again, I'm left with A, B, C, D. Are you getting my point, everyone? And with this 3 times determinant of A will give me 3 square times A, B, C, D's determinant is A only. Now, why did I get this square? 2 I got because this matrix A was originally a 2 by 2. So that property I'm willing to apply here in this question. I hope so far there is no confusion that determinant of Ka is k to the power n times determinant of A, where what is n? N is the order of that determinant or matrix. If you have understood that property, let's try this question with this property. I think now we can do it very easily. Yes or no? With that property brought into picture, I really don't have to take that A as A1, B1, C1, A2, B2, C2, A3, B3, C3, because I hope it is very well understood by you all with this simple idea. Yes or no, everyone? So with this simple idea, if I wish to solve this, it will be done very easily. We won't struggle like that. So here we are. What am I told? What am I told? So there is a matrix B. Let's talk about that matrix B. So that matrix B is simply nothing, but that matrix B you are attaining by operating, performing an operation on 2A. So first of all, there is matrix A, then you multiplied A by 2, so it became 2A. Double of it you got. And on this 2A, what you have done is you have performed an operation on second row. What was the operation? That you multiplied row 2 by 2 and then you multiplied row 3 by 5. Getting it, everyone? Understanding or not? All the participants. So 3 things have happened. A was originally there. You multiplied this matrix by 2. And remember, A was a 3 by 3. So don't forget this order. You multiplied by 2. So it became 2A. And then with this 2A, what you did was you updated row 2 with 2 times of row 2 plus 5 times of R3. If you want to understand it a step-by-step manner, the very broader board level manner, if you want to understand it, you will say that, sir, there was matrix A. I'll do it with this. I'll give you the shorter approach as well. But if you want to understand it with this whole idea that why is it not getting affected, that whole thing I want to show to you, A1, B2, A2, B2, C2 and A3, B3, C3. That whole thing if you do. So first of all, what did you get? Sir, you got 2A. So what will be 2A? 2A will be A1, 2A1, 2B1, 2C1. The next thing will be 2A2, 2B2, 2C2. And the third thing will be 2A3, 2B3 and 2C3. Sir, so far there is no problem. Absolutely no problem. But then what happens next is you make a change. R2 doubled plus 5 times R3. So when we do this, the whole thing, the whole scenario changes here. The whole scenario changes here. First of all, is that part very well understood by you all? Yes or no? Yes or no? So this was our original matrix. If I take its determinant, so this is our 2A. Yes or no? This is our 2A. So here it will be 2, 2, 2, 2, common, 2 common, 2 common, 2 common. So it is 2 cube times determinant of A only. Everybody getting that whole conclusion which I'm coming up with without any confusion, yes or no? But now what happens is that, sir, on this determinant A, this is still 2A, which is 2 cube times determinant of A. Determinant of 2A would have been 2 cube times determinant of A. I hope this property is very well understood by everyone. Now, the next thing which I'm going to do is I'm simply making this thing that this row, second row, I'm multiplying by double of it plus 5 times of R3. And I think the only thing which is happening over here is that, sir, here, forget this. If you are doing this thing, which thing, sir? R2, let me do it. 2 times of R2 plus 5 times of R3. I think it is 5 times of R3. Yes. So with this, what happens here is, this is not 2A anymore. This is another matrix. Let's call it B now, because this is finally B now. If on 2A you are performing this operation, it becomes B. And what is B now? B is R1 and R3 are intact. R1 and R3 are not touched at all. So this remains as 2A1, 2B1, 2C1. R3 also stays like that, 2A3, 2B3 and 2C3. With this, you will understand that proof as well, that why when we perform such operations, the value of the determinant remains intact. But with this too, it will actually get doubled. That also you'll understand very soon. So with this, what have I done here in terms of operations is double of this plus 5 times of this. So double of this means what? 4a2 plus 10a3. Getting it or not, everyone? 4b2 plus 10b3. Everyone getting this? I hope it is not confusing. Then here 4c2 plus, let me just remove this, 4c2 plus 5 into this, that is 10c3. Everybody got this? Now, come back to that whole discussion. Come back to the whole discussion where we were discussing that, sir, a matrix, or rather, if now I'm talking about determinant because I'll be taking its determinant. So let me say its determinant, which means determinant of B. So determinant of B, our determinant can be expressed as a sum of two determinants. Do you remember that whole idea? So first row and third row will remain intact, but I'll split the second row into two other different distinct determinants. Yes or no? With this, your whole job will be done and you'll understand it holistically. Although I did not want to do it in this manner, but I'm doing it because we are running short of matrices. We haven't studied it yet. So we are doing it in a very systematic manner, in a very organized manner. Although in an examination hall, you really don't have to do it if you know the properties. Yes. With this, if I wish to find determinant of B, so with determinant of B, I'll take determinant of this. Yes or no? This will be the determinant of B. Now with this, sir, first and third row will remain intact. First and third row, which means what? In this splitting, first and third row will not change at all. So it will have 2a1, 2b1, 2c1. This will be 2a3, 2b3, 2c3. This will also be, I'm doing it very systematically so that you understand the proof as well of this property that column-wise or row-wise operations, if are performed, they don't change the value unless that same column or same row is not multiplied, which is being changed. So this is how I'll write it. Now this second row I'll split. So 4a2, 4b2, 4c2 I'll write here. 4a2, 4b2, 4c2 I'll write here. And 10a3, 10a3, 10b3 and 10c3 I'll write here. Everybody got that? Everybody got that, yes or no? Now, from here, pay attention everyone. We are absolutely done with this question. How? Here, if I take 10 common from this row and 2 common from this row, are you not noticing A3, A3, B3, B3, C3, C3? Sir, if in any determinant, two rows are identical, the value of that determinant becomes 0. Exactly. Exactly. So with this whole determinant will be 0. Now, with this, if I come back to this, if I talk about this, pay attention everyone. Determinant of B is going to be 2 taken common from the first row, 4 taken common from the second row, and 2 taken common from the third row into, I think I am now left with A1, B1, C1. This is A2, B2, C2. And this is A3, B3, C3. Yes or no? Everybody, give me a quick response. Everybody got this? How did I get it? Everybody, yes or no? So 2 into 4 into 2 into this. And what is it? It is your determinant of A. I think determinant of A, we were told as 4. It was given as 4. So if this part was 4, I think you have the answer. 2 into 4 into 2 into this determinant of A, which is 4. And you know this is nothing but what? No, Nilesh, how to make approach to solve the question of properties. I had to make this entire approach because you at this stage right now don't know the properties of matrices. Congratulations, Madhav. So now pay attention everyone. Here, you don't know the properties of matrices. That's why I got stuck and I had to explain it step by step like this in a very basic manner. You really don't have to do it like this in the examination hall. If you know the chapter matrices as well, you apply it and in 3 lines you'll get the answer. But I could not because you don't know the chapter matrices right now, which will cover after determinants. That's why I did not. Now, So I think it is clearly what? 2 into 4, 8, 2 into 4, 8, 8 into 8, 64. And that I think we are given in option A. Did I do a poll here? No, I did not. But anyways, I'm sure some of you must have cracked it as 64. Yes or no? Yes or no? So shall I move ahead from here, all the participants? With this, if I now talk about the next few expansions, which should be there at your fingertips regarding determinants, this one. The moment you see this 1x square, 1y square, 1z square, don't hesitate in substituting it by x minus y minus z minus x. Please remember it. If you really want to save your time in the examination hall, I'm talking about these competitive exams, JEE Mains and Advanced, there, if you ever see something like this, write it like this, quickly. Don't waste your time. Second conclusion, which you should, this is the proof. You can keep it for yourself. This proof you can avail to be watched or seen by yourself, or to be revised by yourself by having this PDF. Sir, how are we going to have this PDF? This PDF you can have by following our WhatsApp channel. Sir, how are we going to follow your WhatsApp channel? The link is given in the description. You can follow it. Now, the moment you see 1x x cube, 1y y cube, 1z z cube, it is not x square, y square, z square. Had it been like that, I would have stopped here. But if it is x cube, y cube, z cube, then it is written as x minus y, y minus z, z minus x, times whole of x plus y plus z. Next thing. If it is x square and x cube both, which means 1x square x cube, 1y square y cube, 1z square z cube, in that case, this cyclic part, x minus y, y minus z, z minus x, is like that. But here, it comes with another factor, xy, yz, and zx. Getting it, everyone? All the participants? Yes or no? Now, the next thing. We will be solving this question. Shall we? Everyone, paying attention, putting complete focus, yes or no? So, I am told fx is given by this, okay, where x is taking any value from 0 to pi. So there, how do I find the maximum value of f of x? Sir, you can, but first you got to simplify this. You need to simplify this. Now, in order to simplify this, one of the best approaches could be, first of all, by using properties of determinants, let me get a better version of this determinant. And then I'll expand it. And after the expansion, we know how to find the range of trigonometric expressions. We'll do something in the end, but let me start with simplification of this determinant by using the recent standard properties which we have learned so far. Yes or no? So with this, sir, fx is given by this. Indeed, it is given by this. Now, some of you must have been noticing that, sir, if you add two things you can do. From row 1, row 2 can be subtracted. So this and this will get cancelled, this and this will get cancelled, this and this will get cancelled. So something will definitely get. Some zeros you will get it more. And similarly, from this, if you subtract this. So two things I'm doing, two operations, because it is a 3 by 3. So at a time, maximum 2 row operations can be performed. Now, I'm performing 2 operations. In row 2, I am subtracting row 1 from row 2. And in row 3, I am subtracting row 2 from row 3. These are the 2 operations I'm performing on row 2 and row 3. I'm really sorry. This should have been row 2. I hope it is fine now. Row 2 minus row 1 on row 2. Row 3 minus row 2 on row 3. Now, what happens when you do so? Row 1 remains intact. So, row 1 if remains intact, I think the job is really simple. Row 1 is going to be what? Sine square x minus 2 plus cos square x. Okay, so this is cos 2x. You may get confused. I hope it is a square in 2. You don't get confused. Or if you are getting confused, I'll write it properly. It will be sine square x. It will be minus 2 plus cos square x. And this is cos 2x. So don't get confused here. Everybody with me? Now, what am I doing is row 2 minus row 1. So this minus this will give me a 2 here. This minus this. So minus of minus 2 will be 2, and this will get cancelled. So it will leave you with a 2. And this minus this will give you a 0 here. Everybody got that? No confusion? Yes or no? And then row 3 minus row 2. Row 3 minus row 2 means what? This minus this, sine square x are cancelled. You are left with minus 2. Cos square x are cancelled, so you're left with another 0. Cos 2x are cancelled, so you're left with a 1. Everybody got that? So this is how the determinant looks like. Everybody with me? Any confusion so far? How did I simplify this? By using this property? Yes or no? Now, what I do next is a simple task. Which simple task, sir? I will expand it. I think it's better that we now expand it with whichever row or column you wish to. You can. So shall I do it with respect to, let's say, column 2 or column 3? Whichever you wish to take. So let me use column 3. So I hope you remember plus minus plus, minus plus minus, plus minus plus. So this and this will be plus, 0 doesn't matter. You remember that? So cos 2x I'll multiply it by its cofactor, then plus 1 I'll get. And I'll multiply 1 by its cofactor, sorry, minor. So cos 2x will have its minor as 0 plus 4. I hope you're understanding it. 0 plus 4. So this is 4 cos 2x, yes or no? Then I have plus 1. For this one, I hope you're understanding, its cofactor, its minor will be given by this, which is 2 sine square x, yes or no? Yes or no? So this is 2 sine square x minus, pay attention everyone, minus, I hope you're understanding it. So minus of 2 into minus 2, which is minus 4. So this is plus 4. Then minus 2 into cos square x is minus 2 cos square x. Shall I repeat that part? Nilesh, have patience. Just go through the whole theory, or rather one shots. We are doing this determinant one shot right now. Watch it completely. And then we'll do matrices one shots. Watch that completely and then solve previous year's questions. I'll come back to this. I repeat, first thing which I did was for cos 2x, it was 0 plus 4. So that was 4 cos 2x. For this one, I expanded it with respect to column 3. This one, I hope you're understanding, this into this, sorry, this minus this, so 2 sine square x I got, and then I got minus of 2 into minus 2, that's plus 4, and minus 2 into cos square x is minus 2 cos square x. That's how your determinants expansion look like. I think it's really simple now, because this here, can I do it here if it is not confusing at all? So here, 4 cos 2x stays like that, you don't touch it at all, but here, 2 sine square x, 2 cos square x. If I take 2 common, or rather minus 2 common, it will be cos square x minus sine square x. Do you remember that identity? Cos square theta minus sine square theta? No, not 1. Cos square theta minus sine square theta is cos 2 theta. So that will be 2 cos 2 theta, but it is cos 2x. And this 4 stays like that only. Everybody getting that? Yes or no? Now with this, your job is done. Your job is absolutely done. Why? Because now what will you say? 4 cos 2x minus 2 cos 2x, that is 2 cos 2x plus 4. I think you know how to find its range. What are we asked? Sir, you need to find the maximum of f of x. Maximum of f of x. So if I want to maximize it, can you tell me maximum value of cos 2x is 1? Minus 1 to 1 it stays. So it's 1 maximum plus 2 plus 4 will be its maximum value. So 4 plus 2 is 6. Your answer would have been 6. Everybody got that? Everybody understood that? Yes or no? All the participants. It was easy, doable. How many of you cracked it? How many of you got the answer? How many of you were able to actually do it? Or if you have used some other approach, some other idea, do tell me. I'll be really happy. With this, shall we move towards the next thing? So this is what we'll be doing now. Give me a moment. I'll be back in a minute. Just give me a minute. कॉफी दे दो यार, बिना शक्कर के देना. कॉफी कॉफी कॉफी. So determinants are so beautiful in nature that with them you can deal with some problems based on coordinate geometry as well. What do I mean by that? I wish to say here a simple fact that if you have, let's say, a triangle which has vertices x1, y1, x2, y2, x3, y3. So if you simply find out a value, which means x1, y1, 1, x2, y2, 1, x3, y3, 1, it's determinant. And the mod of that value, because it is going to be the area. And if you do half of it, trust me, that will be the area of the triangle which you are forming by joining x1, y1, x2, y2, and x3, y3. Sir, what if they are collinear? No triangle will get formed. And if no triangle is getting formed, area has to be 0. So if you wish to prove that 3 points are collinear, one method is slope method, other method is distance method, third method, this determinant x1, x2, x3, y1, y2, y3, 1, 1, 1, this determinant can be proven as 0. Can I give you something really different today? Stair method. Sir, what is the stair method? Some of you could already be aware of because you must have studied in 11th standard coordinate geometry. But if you haven't, this is again one of the most useful approaches which you can always think of. Let's say there is a polygon. I'm taking a triangle, but it is true for any polygon if you don't ruin its cyclicity, if you take it either in clockwise or anti-clockwise manner. So let's say there is a triangle and I want to figure out its area. How do we find out? Determinant method. The second method is that you can use stair method. Now stair method says the area of this triangle is given by x1, y1, x2, y2, x3, y3, and then again you write x1, y1. This is the stair. Sir, so far we were already studying determinants. Now you have introduced stair. How do we expand it? I'll tell you, don't worry. But you take stair of it, then you take mod of it, and then you take half of it. Sir, are you not making any mistake? x1, y1, x1, y1? No. With whichever vertex you start, you write that vertex once again. For a triangle, 4. For a quadrilateral, there will be 5 such elements because first vertex gets repeated and you maintain that cyclicity. So what does the stair say? If you come from left to right, of course, up to down you will follow. From left to right, it will be plus. From bottom to up, minus. From up to bottom, plus. Bottom to up, minus. Up to bottom, minus. Top to down, or whatever you want to call it. And from bottom to up, it is minus. Which means, if I wish to write its expansion, it is half of mod of x1, y2 minus x2, y1 plus, I hope no confusion, x2, y3 minus x3, y2. Getting it, everyone? Plus x3, y1 minus x1, y3, and that's it. Everybody understood that? Let us understand all what we have discussed so far with an example. Let us understand that. By the time I do it, you also try it. Then we'll discuss it together. Okay, so here we are. Either you can use determinant method or stair method, whichever you wish to use. Let's use the stair. So what does the stair say? Sir, half of mod of stair of 3, 2, 11, 8, 8, 12, and then 3, 2 again. With whichever vertex you start, you repeat that vertex in the end. So how do we apply stair here? Pay attention, everyone. It's really simple and straightforward. 8 into 3, that's 24. So half of mod of 8 into 3, 24, minus 11 into 2, that is 22. Plus 11 into 12, what is 11 into 12? 2 plus 3 plus 1, I mean 132. If you didn't get it, all I did was 2 plus 1, 3, and then 1. So 132. It will be 132. Then With this, if I now go ahead, what did I see next? I think this is what we did. Now 8 into 8, that is going to be 64, but with a negative sign. Plus 8 into 2, that is going to be 16. And then 3 into 12, that is 36, but bottom to up minus. It's mod, and that will be your answer. So will you calculate it by yourself now? Yes or no? Shall I repeat it? I repeat, I hope it's easy, half of. I hope 24, 22, 132, 64, 16, and 36, you can add it all up. Half it, and don't forget to take mod because it is area. So I hope you'll do it. Everyone, yes or no? Did you all get complete clarity on the stair method? Sir, what if we don't want to use a stair? Can we do it? Yes. How? By using determinant. Determinant also will give you the same result, but if you want, I can just write the expression for you, but you got to figure it out by yourself. Sir, with the determinant, the area will be given by half of mod of determinant of x1, x2, x3, that is 3, 11, 8, y1, y2, y3, that is 2, 8, 12, and then last column can be 1, 1, 1. And if you expand it, that will also give you the area. Yes or no? Everyone got this? Everyone understood this? Can I move ahead from here? Now, I am told that if I wish to verify that 3 lines are concurrent. What do you mean by lines being concurrent? What do we mean by lines being concurrent? Lines being concurrent means, let's say there are 3 lines like this, and this. And I'm told that these 3 lines are concurrent. So concurrent means, just give me a second, everyone. Let me just remove some unnecessary elements who are simply wasting our time here so that we can focus on some dedicated, detailed, decent, healthy discussion. Let me remove some irrelevant elements. No worries. Definitely, sorry. Keep studying. Okay, so let's stay focused. Let's talk some relevant let's have some relevant discussion. So if 3 lines are said to be concurrent, it means that all those 3 lines are passing through one single common point. Now, one of the ways or methods is that you solve any 2 lines first. You find their point of intersection and make that third line satisfy that point of intersection. That's how you can check these 3 lines are concurrent. But sir, if I don't want to use such a lengthy approach or method, what other alternative do we have? The other alternative says, if you want to check that 3 lines are concurrent, you can check it with a very simple idea that take the determinant of the coefficients and the constant, which means 2, 1, minus 1, a 3, minus 3, 3, 2, minus 2. And this determinant, you put equal to 0. If this determinant is found to be 0, your lines are concurrent. If this is not 0, the lines are not concurrent. This is a recorded class. No, online. Live class. So here we are. I am told that these lines are already concurrent. So I don't have to check it. I need to apply this condition where the coefficients and the constant terms determinant is going to be 0 because these lines are said to be concurrent. So I think I can use either standard expansion or Sarus rule. Shall we again go back to the Sarus rule because it is simple, it looks easy. So can I use Sarus rule here? I hope you're okay with that. So with Sarus rule, what is going to happen? So repeat the first 2 rows. So if I repeat the first 2 rows, it will be 2, 1, minus 1. Then I'll have a 3 and minus 3. Any confusion so far? So with this 2, 3, minus 2. So 4 into 3, that's 12, but minus 12. Getting it, everyone? Then a2 minus 1, that's minus 2a. This is minus 2a. Then 3, 1 minus 3. How much is that, students? That is minus 9. Minus from this product, the other product. This 3, 3 minus 1, that is minus 9. Then minus 3, 2, 2, that is 4 into 3, 12, which is again minus 12. And this is 2, 1a, which is, did I make any mistake? 2, 1a. 2, 1a. Are we sure about this? Because I think there is some problem now. Because it is independent of a here. Because this is turning out to be 0 irrespective of any value of a. Let me recheck it. 2, 1 minus 1. A 3 minus 3. 3, 2 minus 2. So 2, 1 minus 1. A 3 minus 3. With this 3 into 2, 6 into 2, 12. Then minus 2a. Then minus 9. Yes. Then minus 9. Then minus 12. And then this is minus 12. Wow. Luckily, what is happening here is, pay attention everyone. I hope you are clearly seeing minus 12 are cancelled, minus 9 are cancelled, minus 2 and minus 2 are also cancelled. 0 is equals to 0. I was hoping that I could get something on the LHS in terms of A, plus or minus something, and there I'll crack A as to be something. But I did not get anything. I got LHS and RHS both to be 0, which means it became an identity, which means it is not dependent on A. Which means irrespective of whatever value of A you put here, it will always be concurrent. So it does not depend on A. A can take any real number. Did you get this? Find the values of A. I'll say A can be any real number. For any real number A, I'll be saying that these three lines are going to be concurrent. Everybody got that? Yes or no? Everybody understood that? With this, let's move ahead with the next concept. So far, is there any confusion on whatever we have done? Yes or no, all the participants? So with this, let's talk about condition for second degree equation. This is what you must have studied when you would have gone through coordinate geometry, pair of straight lines. Second degree equation. Do you remember that in two variables? Do you remember that? What am I saying here is that ax square plus by square plus 2hxy plus 2gx plus 2fy plus c. This equation in two variables, which is second degree equation, can represent either a pair of straight lines or conic sections. Do you remember that? Conic section means circle, parabola, ellipse or hyperbola. Which means, just give me a second everyone. Let us just get rid of some unwanted elements. And with this, let us resume so that we stay sorted. Coming back to the discussion. Pair of straight lines or conic section it is going to be. Now, if I wish to validate or verify that this second degree expression will represents a pair of straight lines, then it will happen only when A, B, C on the principal diagonal and H, G, F here and here. If this determinant is found to be 0, if this determinant becomes 0, then I'll say that this will represent a pair of straight lines, otherwise conic. Non-zero means conic. Got this, understood this? Will you apply this when you solve the questions? Now, some of you was asking, sir, I am always confused with the product of determinants. You should not, you don't really have to. You can really simply do it with the way you do with matrices. With matrices, what we do is rows and columns. But the beauty with determinant is row by row, column by column, row by column, or column by row. You have 4 ways of multiplying a determinant. What am I saying is, let me explain with a simple example. Let's say there is a determinant delta 1, which is given by, let's say, 2, 3, 1, minus 1. There is a determinant delta 2, which is given by, let's say, 4, 1, minus 2, and 0. Any value you can take. And there, of course, what do I mean by this? Delta 1, if you wish to find, how will you find it? Delta 1, you can find 2 into minus 1, minus 2. 3 into 1, that is 3. With minus 3, it is minus 5. Delta 2 is going to be what? 0. Minus of minus 2, that's 2. So if I ever ask you delta 1 into delta 2, what will you say? Minus 5 into 2, minus 10. So it is going to be minus 10. It is always going to be minus 10. Undoubtedly minus 10. But let's say I don't do it like this. I am interested in making it unnecessarily complicated. I want to multiply those determinants first and then find out its expansion. What will happen then? Let me talk about that result. Pay attention, everyone. I'm saying something really interesting. If you are paying attention to, you'll understand it. All what I'm saying simply is nothing but this. Let's say I want to take this product. Which product, sir? Delta 1 into delta 2. So delta 1 into delta 2, how will it look like? It will look like 2, 3, 1, minus 1 into 4, 1, minus 2, 0. Now, all I'm saying is determinants can be multiplied row by column, row by row, column by row, or column by column. With all of these 4 ways, you will get the same determinant. Trust me, mark my words. What I'm saying here is, let me give you a very simple example here. I have chosen rows from here and columns from here. Let's say I'm doing row by column the way we do with matrices. The same logic I'm using here. This is also what you can do. So 2 into 4, that's 8. 3 into minus 2, that's minus 6. Then 2 into 1, that's 2. 3 into 0, that's 0. This is how you do determinants multiplication. Then minus 1 into 4, that is, sorry, 1 into 4, 4. Minus 1 into minus 2, getting it, everyone? That is plus 2. Then 1 into 1, that is 1. And minus 1 into 0, that is 0. This is delta 1 into delta 2. How much is that? Let's figure it out. 8 minus 6, that's 2. 2 plus 0, that's 2. 4 plus 2, how much is that? 6. And 1 plus 0 is 1. Yes or no? So I repeat, 2 into 1, 2. 6 into 2, 12. Can somebody help me with 2 minus 12? I think that's minus 10. Got my point. Understood my point. Have you all seen this happening in front of you? Did you all get this? Sir, you have done it row by column. Can we do it row by row? Yes, you will still get the same value. Can we do it column by column? Yes. Can we do it column by row? Yes. Whatever you do, are you understanding the process? Have you gotten the process? Yes or no? Everybody, give me a quick update. So far, yes or no? So, I think this is what we have discussed. But this property I will ask you to remember, because this is what we'll be using in matrices as well. What is this property? What does this property say? Let's talk about that. Let's say there is a determinant delta which is given by A1, B1, C1, A2, B2, C2, A3, B3, C3. And I'm writing the cofactor of it. Cofactor means the cofactor of small a1 is capital A1, cofactor of small b1 is capital B1, cofactor of small c1 is capital C1, and so on. Do you remember cofactor? I hope I don't have to recall you. The first slide, I think, we covered cofactor. I hope you remember. A1, the cofactor is going to be this into this minus this into this with the sign scheme followed. So for this A1, sign will be plus. I hope you remember that. So these are all those cofactors. Now, the property says that if you find the determinant of these cofactors, this is the determinant of cofactors of this determinant. Understanding my language? I repeat, A1's cofactor is capital A1, B2's cofactor is capital B2, and so on. So of all these elements in this determinant, if I write their cofactors and if I wish to find out the determinant, you really don't have to find the determinant. If you know the determinant here. If this determinant was delta, this determinant will be delta to the power 3 minus 1, order minus 1. Delta to the power n minus 1. Are you understanding? Are you getting what I'm saying? If you are still confused, first of all, just remember this property. I'll explain it with one of the examples. Don't worry. I'll explain it with one of the examples. Let's say there is a determinant delta, which has elements 2, 3, 5, and let's say 1. I want you to find out its cofactor. Yes, I'm repeating it. Have patience. I'm explaining it with an example. So cofactor, how do you find? Before I find its cofactor, are you okay if I write its minors? So for 2, minor will be 1. I hope you're getting it. For 3, minor will be 5. For 5, minor will be 3. And for 1, minor will be 2. Because what you do is, for 1, you'll remove the row in column. And 2 is what you're left with. So this is the minor. But it is not the cofactor. Cofactor, you will get by introducing sign scheme. So this position is first row, first column, 1, 1. 1 plus 1 is 2, even, plus. First row, second column, 1 plus 2, odd. You are supposed to put a minus. Second row, first column, 2 plus 1, 3, odd, minus. 2, 2. Second row, second column, 2 plus 2, even, plus. So this is your cofactor. Now, what did I just say? Can you help me with the determinant here? Sir, this is 2 minus 15. Yes or no? So 2 minus 15 is how much? No confusion, I think, so far on whatever is done. So it is going to be minus 13. Yes or no? Everybody, give me a quick update so far. Is it understood by everyone? Now here, if I ask you to find out its determinant, you really don't have to do it like this. You can directly say that the determinant is going to be equal to delta. That means this raised to the power n, which is the order, minus 1. So delta to the power 2 minus 1 is delta, which is going to be delta only, which is going to be minus 13. Sir, can you prove this? Yes. Idea is really simple. That here 1 into 2, 2. 3 into 5 is 15. 2 minus 15 is minus 13. So everybody got this. But had it been a 3 by 3, it would have been delta to the power 3 minus 1, which means delta square. Are you all understanding this or not? Tell me honestly. So far, whatever I've done, is that understood by everyone, all the participants? Give me a quick response. Yes or no? Can I move ahead from here? So if it is a 3 by 3, I hope you know how to do it or how to deal with this. If it is a 3 by 3, the determinant of cofactors of that determinant will be delta to the power 3 minus 1. That is 2, delta square. Remember it. This property is a very, very useful property. Now, system of equations. I'll directly come to that part with which we were supposed to begin our discussion, and I tried doing it because I wanted you to understand that determinants actually came with this when Cramer came up with this law rule. Let's say I have two equations in two variables. So a1x plus b1y is equals to d1, a2x plus b2y is equals to d2. Now I'll define three determinants. Which three determinants? First determinant, delta. Delta will get formed by having a1, b1, a2, b2. So a1, b1, a2, b2, that is coefficients of x and y. Coefficients of x and y will give me the determinant delta. Now, I'll define two more determinants, delta 1 and delta 2. Sir, delta 1 is going to be nothing. But if you substitute the coefficients of x, by the constant terms, that means a1, a2 are substituted by d1, d2, then you get delta 1. In the same manner, can you define delta 2? Will you all not say that, sir, if you wish to define delta 2 will be given by this very simple idea that now keep coefficient of x as it is. Now substitute coefficient of y by the constant terms. So keep a1, a2 as it is, but b1, b2, you should substitute by d1, d2. Getting it or not, everyone? Yes or no? So with this, delta 2 will be a1, a2, d1, d2. Now you know how to expand it. I hope you know. This minus this, this minus this, and this minus this. So you have delta, delta 1, delta 2. Sir, why did we do this? We did all of this because of a very simple reason, that the variable x will be given by delta 1 by delta, and the variable y will be given by delta 2 by delta. Sir, this was already very simple. Don't you think you have complicated it unnecessarily? I know that. Then, sir, why did you do it? Because I took a very simple example to explain a little bit complex concept. If we apply it, the same logic on a 3 by 3, I think the job will be really easy. I'll come back to this, don't worry. I'll come back to all of this, don't worry. But let me take the same scenario based example for a 3 by 3. Let's say there is a system of equations a1x plus b1y plus c1z is equal to d1. Noticing it, everyone? Similarly, second equation will be a2x plus b2y plus c2z is equal to d2. Third equation will be a3x plus b3y plus c3z is equal to d3. So now I'm dealing with system of linear equations in 3 variables. So I'm having 3 equations. There also, this Cramer's rule can be applied. There also, this Cramer's rule can very easily be applied. How? Let's talk about that. So Cramer's rules say that you define delta first. What is delta? Coefficients of x, y, z, which is a1, b1, c1, a2, b2, c2, a3, b3, c3. Similarly, you define delta 1, delta 2, delta 3. What is delta 1? Delta 1 is going to be substitute the coefficients of x by the constants d1, d2, d3. So a1, a2, a3 are replaced by d1, d2, d3. But other two columns, that is coefficients of y and z, remain same. Getting it or not, everyone? I hope you are understanding it. Yes or no? So, if I wish to define delta 2 and delta 3, are you getting the sense that delta 2 and delta 3, what is going to happen? With the delta 2, the second column, the coefficients of y, will get replaced by d1, d2, d3. And with the delta 3, the coefficients of z, that is the third column, c1, c2, c3, will get replaced by d1, d2, d3. Everybody got that? Yes or no, everyone, all the participants. So far, is there any confusion? Now, I am taking this session live, my dear children, my dear siblings, my dear younger brothers and sisters. If you have defined delta, delta 1, delta 2, delta 3, these 3 things, your job is done. If you want to find x, y, and z, trust me, where shall I write it? Shall I write it here? Will that be understood by everyone? If you define x, it will be given by delta 1 by delta. If you want to find y, it will be given by delta 2 by delta. If you want to find z, it will be given by delta 3 by delta. That's it. Yes or no? Everybody understood that? Everybody got that? Shall I move ahead from here, all the participants? No confusion so far, I believe so. With this, few things I want to give you clarity upon that here. I hope you remember, whenever somebody says unique solution, do you remember unique solution in 10th standard? You must have studied a1 upon a2 is not equal to b1 upon b2. That thing here in this case is given by delta not being 0. But sir, if delta 1, delta 2, in this context I'm saying right now, in this context I'm saying, if delta 1, delta 2, they all are 0. Just give me a moment, students. Let me remove some unnecessary elements so that we stay focused and nothing unnecessary disturbs us, right? So I am coming back to the discussion. Here we are. Pay attention, everyone. So first thing, whenever you see delta to be non-zero, whenever you see delta to be non-zero, you say that it will be having a unique solution. But sir, if I want to say it has infinite solutions, if I want to say that it has infinite solutions, in that case, what is going to happen is delta 1, delta 2, they all will be 0. But sir, the third case, what is the third case? The third case is, let's say, no solution. So what do you mean by no solution, sir? In that case, delta will be 0, but at least one of delta 1 and delta 2 will be non-zero. That's the case of no solution. The same you can apply with the 3 variable set as well. Did you all get this? Did you all understand this? Yes or no? Everybody. Shall I move ahead from here, all the participants? Did you all get this whole idea? And that's exactly what is written over here. This all is explaining that whole part only. Consistency and inconsistency I'll explain. Don't worry about that. So that part I'm going to cover now. So system of equations are said to be consistent or inconsistent. Consistent means they have solution. So they have either unique solution or they have infinite solutions. But they are said to be inconsistent if they have no solutions. First of all, are you getting this classification on system of equations I'm doing? Everybody getting this whole idea? Now, when you talk about unique solutions, I hope you remember unique solutions means the only condition you need to check is delta should be non-zero. For infinite solutions, delta, delta 1, delta 2, delta 3, they all should be 0. And for no solutions, delta should be 0 and at least one of delta 1, delta 2, delta 3 should be non-zero. Just keep a screenshot of this slide. I'm giving you that in a short manner, you are going to see a question from this slide in JEE Mains. Trust me. Trust me. I repeat. This concept-based questions are always asked by JEE Mains. They sometimes ask you system of equations, and then they give you what should be the condition for unique, what should be the condition for infinite, what should be the condition for no solution. Savish Gupta, I think I have already answered this question. Had you been watching it from the beginning, you may have noticed, but I'll have to trace it back to that slide. Let me find, where is that? Here we are. So this is what I said, that solve PYQs of mains from 2020 to 25 and then advanced 2000 to 26. If you are really sincerely doing it, you really don't have to focus anywhere else. Trust me, for JEE Mains and advanced both. Now, for advanced, of course, you need more practice, but yes, a decent understanding you will definitely build with that. Now, here we are with the final concept, which I'll be covering with this idea. Let's say this is a question, but before I come or talk about this question, I want to talk about this homogeneous system of equations. What do you mean by that homogeneous system of equations? This is said to be a homogeneous system of equations. A1x, B1y, C1z, D1 is 0. A2x, B2y, C2z, 0. A3x, B3y, C3z, 0. They all are getting satisfied by 0, 0, 0. Are you not noticing it? If you are imagining it in 3D, are you not noticing that, sir, they all are getting satisfied by 0, 0, 0? Yes or no? Yes. So, of course, 0, 0, 0 is said to be the trivial solution here. Trivial solution means that 0, 0, 0, if you put in first, second, and third equation, all the 3 equations will get satisfied, and this will have solution as 0, 0, 0, which is called the trivial solution. But sometimes what happens is that these system of equations have non-trivial solution as well. Sir, what do you mean by that? Actually, in 3D, there are 3 planes. In 3D, they are representing 3 planes. Planes, I hope you understand, just like the sheet of your paper, the phone, this is a plane. The wall, the floor, the board on which I'm teaching, they all are planes. Plane. So, let's say this is a plane. This is another plane, let's say. Right? Like a laptop, you may say. And there is one more plane, let's say. How do I draw it? Let me do it. There is one more plane. Give me a moment, students. this. So imagine that there are three planes like this. Are you able to imagine this? In 3D, you should be imagining this. Absolutely, absolutely, absolutely. So these are the three planes. I hope you're able to imagine this in 3D. This is plane 1, let's call it P1. This is plane 2, let's call it P2. This is plane 3, P3. So when you are saying that A1x plus B1y plus C1z is equal to 0, that's your plane 1. This is your plane 2, A2x plus B2y plus C2z is equals to 0. This is plane 3, A3x plus B3y plus C3z is equals to 0. And the beauty of all three of these planes was that they all were passing through origin, because 0, 0, 0 was satisfying it. Sir, in this case, are you not noticing that, sir, there are infinite points? There are infinite points which are satisfying plane 1, plane 2, and plane 3 all simultaneously. Yes. It may not always happen, but luckily in this case, it is happening. Which means all these planes are intersecting on a line. If you are not able to visualize this, imagine this, that you are sitting in a room. You are, I think, sitting in a room. And in that room, you are having a floor, a wall, and another wall. So these three walls, you need to imagine it like this. This is your room in which you're sitting right now. This is your room in which you're sitting right now. So you're sitting somewhere. Then look at these three walls I'm noticing, highlighting right now. This is your floor, let's say, on which you're sitting. This is the wall adjacent to it, and this is the front wall. So I am asking you to put your complete focus on this point here. This is that point which is common to all of these three walls. Yes or no, everyone? This is that common point which is common to all of these three walls. Yes or no? So if this is that common point which is common to all of these three walls, this is case that this could be the origin. But there could be planes placed like this, just like your copy, your notebook. You take any 3 pages of it. Those are 3 planes, and they are intersecting at a common line where all those pages are joined. So this is that line, and that line is common to all the 3 planes. So all the points lying on that line will satisfy all the 3 planes. So this can be said a case of trivial solution where only one point is satisfying all the 3 planes simultaneously. But this case here is said to be the case of non-trivial solution, although I'm not explaining it holistically the way we do it in the proper classes, because there we have more time. I give all the cases there, I make them visualize all the cases, but I hope you got it holistically. What do I mean by non-trivial solution? So if apart from origin, if there is another triplet as well which is satisfying the system of equations, then it is said to be having non-trivial solution. Trivial means 0, 0, 0. So apart from 0, 0, 0, there is other solution as well which exists. Then we say that it is a non-trivial solution. So how do we ensure, or when do we ensure that it has a non-trivial solution? If A1, A2, A3, B1, B2, B3, C1, C2, C3, its determinant is non-zero. What did I just say? I'll demonstrate it. I did it. I did it. You watch it properly. I did it. I have already done it. Sound wave sync. So A1, A2, A3, B1, B2, B3, C1, C2, C3, if I do here, because it has non-trivial solutions, I will get the answer to this question. How? I hope you're understanding. What is A1 here? That is 2A. What is A2 here? That is -2. What is A3 here? That's 3. What is B1 here? 1. What is B2 here? A. What is B3 here? 2. What is C1 here? Coefficient of X, that's 2. What is C2 here? Coefficient of Y, that's 0 because no Y. C3 will be coefficient of Z, that's A. And if it has a non-trivial solution, if it ever shows non-trivial solution, then always remember the determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3 is going to be 0. So just solve this, you will have your answer. How are we going to do this? Let's do it. So can I use again the Saras rule? So 2A minus 2, 3, 1, A, 2. Do you remember Saras rule? We have been doing it since the beginning. So with this 2A, I hope you're noticing it, 2A, that is 2A to the power 4 plus 103 is 0, 2 minus 2, 2, that is -8. Yes or no? Everybody got this? Minus this. How much is it going to be? 3 into 2 into A, right? That was 2 into minus 2 into 2. That was minus 8, yes. 3 into 2, 6. So it will be 6a. Then I'll have this, which will be 0. And then I'll have this, which will be minus 2a undoubtedly. And this should be 0. Yes or no? So with this, I hope no confusion so far. 2a, then a, then a. Yes, it is 2a to the power 4. Okay. So with this, it is 2a to the power 4 minus 8. 6a minus 2a is, I think, how much? 4a, but it should be minus 4a is equal to 0. Yes or no, everyone? So are we getting any solution here? Because it is biquadratic. Hidden trial, is it helping us? Because 1 is not satisfying it, right? 2 may or may not. I hope I'm not making any mistake. I hope it is 2a only, because 2a minus 2, 3, 1a, 2, and 2, 0a. So 2a minus 2, 3, 1a, 2. I don't know. So this will be 2a, that's 2a to the power. Oh yes, I'm really sorry. I was making a mistake. I was making a very silly mistake and nobody in the comment told me. Nobody in the comment told me. It is 2a into a into a. So it is 2a cube. It is going to be, I'm really sorry, going to be 2a cube. So this has to be 2a cube, right? So I think it is very well sorted now. 2a cube minus 4a. Even you can take minus 2 common. So it is a cube minus 2a minus 4 is equal to 0. Right. So anything satisfying it? With 1, of course, not, because no, but with 2, I think yes. With the 2, yes. Yes. So I hope you're noticing that if a is 2, 2 cube is 8, 4, 4, 8. So it becomes 0. So a is equal to 2 is one of the solutions. So find the value of a. One of the values of a is going to be 2. Can we have some more values of a? Let's find it out. Let's find it out. I hope you remember polynomial division, factor theorem, remainder theorem. If I use all of them, I'll be done. So how are we doing it? Let's apply that logic. So a is equal to 2 is satisfying it, which means a minus 2 will be one of its factors. So other factor, I'm willing to find out. So this is a. This is a. This is a cube. So I got to have a square here. So a square into a will make it a cube, yes or no? But a square into minus 2 will make it minus 2a square, yes or no? Sir, you don't need minus 2a square, you need minus 2a. Okay, I'll bring minus 2a later, but I got to remove minus 2a square. So I hope in order to bring up plus 2a square, this is a already. So should I not have 2a? Because 2a into a will be 2a square, but 2a into minus 2 will be minus 4a, yes or no? So you have unnecessarily created minus 4a, but what you need is minus 2a. So with minus 4a, if you add a 2a, I think you'll get minus 2a. So to make a 2a, where I'm already having a, I need to have 2, because with the 2 into this minus 2, I'll get a minus 4. So I think everything stays balanced. Getting my point? I hope nobody's getting confused. Yes or no, all the participants. So with this is how you factorize it. Now, if you find out its discriminant, it will be b square minus 4ac, which is negative. So this quadratic cannot be solved. The only solution is a is equal to 2. Everybody understood that? Everybody got that? Any confusion so far? Have you all gotten a decent clarity on this? Yes or no? Yes or no? So we tried covering a lot of things. Not wholly, totally, absolutely, because one shot you don't study everything, but almost up to a great extent, almost everything. But are we really done with this chapter? No. Sir, when are we supposed to be done? When you are practicing a lot of previous year's questions. At least last 6 years PYQs of JEE Mains you should be doing. I hope no confusion so far. So I am calling it a day from my end, and I'm assuming that you have understood it to a great extent. You have gotten a really great clarity on this chapter. You have gotten a very good understanding of this chapter. Shall we meet in the next class with matrices? I hope you must have learned and enjoyed. Those who have been sincerely watching it, thank you so much for your patience. I tried my best. Let's meet in the next class. Thank you so much. You have been a great audience. Take a good care of yourself. Good night, everyone.